Hello YouTube, this is Dazza the cameraman. Today is Sunday, April 28th here in New Zealand, Saturday, April 27th elsewhere in the world. And I'm very pleased to have with me some special guests for this discussion. I've got Mr. Thrive and Survive. Rich, welcome along.
Thanks, good to be here.
And I've got Mike Boll as well. Hello, Mike.
Hello, Dazza.
And I've got Astronomy Live joining us as well. Thank you for joining us, Astronomy Live.
My pleasure.
And we've also got Shawn Hufford in the background, who is our technical support. He may be joining us for some discussion a little bit later on, but first of all, we're going to cover the main topic, which is Mr. Thrive and Survive's lunar leap moon rotation videos, which we've been discussing for just over 2 months now. So back on February 16th, I believe it was, Mr. Thrive and Survive and Mike Boll were both filming the moon and believed that they recorded an abnormal rotation of the moon, or what they've been calling a lunar leap. So we're going to be looking at that. And so I'd like to thank you, Rich and Mike. Thank you for joining me and having the testicular fortitude to actually show up, which is more than what a lot of people will do when actually challenged to do so. So as I've said, I've undertaken to be respectful and polite. We won't be talking over each other, but I'm sure that we can have a lot of fun along the way. So now to the burning question that everybody wants to know. Rich, did you ever get that parcel open?
I'm sorry, did I ever get the what open?
The parcel.
The parcel.
You remember you're trying to open that parcel? Everybody wants to know, and was it a new set of headphones?
Yes, it is a new set of headphones.
Right, okay, I did warn you that I'd use a bit of humour, so tush. Okay, but seriously, I appreciate you both joining me, which is, as I say, is more than most will do. And I will ask some hard questions. Some of them I have already asked, but we'll ask again so that we can provide the complete picture. Now, Mike, you have some very nice gear there we've seen in some of your videos. Would you like to give us a rundown on what you are using, please?
I was using Skywatcher Star Adventurer EQ Astro trackers, Astro mounts, and on a EQ wedge, I got a P900 that once the P1000s came out, I converted that to infrared. So I think the picture you're showing right now is that's just me out there by myself with both my cameras. But that's basically it. I've got, oh, and everybody knows by now about the slick micro adjuster.
Right, yep.
So, but that's about it. On the 16th, we had basically that same setup, except for I was not using the infrared camera. Rich had his P900 on my other setup.
Right. Now in this image, we're seeing your P1000 on your mount there.
Right.
And there's one other image. So there's the P900 and the P1000 side by side. The P900 on the left there, which is the one that you've converted to infrared by removing the infrared cut filter, I assume.
Yeah, I sent it out. I didn't do it, but yes, that's what it is now.
Right, and we've got the moon there in the middle as well.
Yeah.
Okay, now Rich, you were using your own P900, I assume?
Yes, we weren't using Mike's infrared. I was using my P900, which is not converted, and we were also using a B700 on a standard mount.
Right. Now, have you actually posted that video? Just in case I've missed it, have you posted your own video of your P900 footage at all?
Yes.
You have?
Yes, it's on probably I can try to remember if it was the first or the second one I talked about it, because what happened was someone took that video and actually stabilized it better, and it's a better link, the person that stabilized it, but yeah, it's on there.
Okay, because and correct me if I'm wrong, my understanding from the first videos was that you had presented a number of screenshots from the videos, and I do recall that there was video, but I thought it was the video taken by your friend, which I had now assumed was Mike Boll.
No, it was my video on the P900
Okay.
that I showed.
All right. Okay. Hopefully you're seeing. I've just got the public link on my laptop so I can see what's being viewed as well. There it is. Okay, so these are Mike Boll's videos, and of course the recent ones are about the lunar leap. So I think we'll probably start with this one here just to set the scene. Open that in a new tab so I can keep that one there. So this is this Rich's footage or yours, Mike?
This is my footage with the P1000.
Okay. So probably what I need to do is to go to Mr. Thrive and Survive's channel and pull up that video, or are you able to send us the link?
You actually, I just actually saw it in the list because I gave it to Mike. If you go back to that, it's the very first one. Isn't that the one, Mike? The one that's 5 minutes 4 seconds?
Of course it is. Yeah, that one there.
Yeah, it's all broke up. It's not merged together. I do have his merged together. I think I uploaded it. That's where I was just going. You wanted the individual timestamps of the individual time lapses, and so this video I just went through one by one and
okay. If you do have the original there, can you see it there at all?
Rich's stuff all merged?
Yeah.
Yeah, I've got that. Hold on. I've got Rich's merged, and then I've got us both together merged. Let me find Rich's merged. I'm seeing both of them merged.
Because if not, I can just play it from here. But I think if you've got it merged where you've done it properly, then that would be better.
Yeah, I just got to figure out where I put him. So I'm looking. Sorry. It's, P900. Find out here. Hold on. Okay. Yeah, I got Rich merged here. So let me. And.
Do you need a few minutes to look for that, Mike? Because if you do, I'd like to show you how this all started.
Okay, you're going to share your screen, or are you just talking?
I'll share the application.
Okay, and I'll present you when you're sharing.
Okay.
Okay, so you're presented now.
Okay. What started this was just going through MoonCalc and just taking a look at what they were presenting here. And what I'm going to do is, I don't know if it will be big enough on the screen to show, but do you see over here where it's showing the moon, the lit part?
Yep.
What I'm going to do is I'm going to scroll through from the time it starts, which is moonrise here. This was done in Mesa, Arizona, February 16th. Now, this 1500 UTC, we're -7. We didn't get the first hour, I would say, because it was cloudy, and that's why you see a lot of clouds early in the video. I mean, we see it a little bit, but we didn't get probably this first little bit right here. But after that, we were good. So if you look at this, though, I don't know if it'll show. You can go here, mooncalc.org. You see how it's showing a counterclockwise rotation right there?
Mm-hmm. You're talking about over on the left-hand side there, you've got a little preview of the moon next to the data.
Right, exactly. Well, that's what started it. So, and we were expecting, and that didn't make sense in the model to me. So I was like, well, why don't we just try to capture and see if we see this counterclockwise move? And again, I'm scrolling. Let me see. What starts about there? And let me see if I can get it in. It looks like it's over about a 2 or 3 hour period where it turns counterclockwise before it stabilizes, and then at meridian crossing, or even before meridian crossing, it shows it going the other way.
Mm-hmm.
So we were expecting over a 2 hour period to catch this gradual counterclockwise move. That's what we were looking for.
Mm-hmm.
And that's not what we saw. We saw what we can narrow down to is about 7 or 8 minutes.
Mm-hmm.
And I'm sure that's what we're going to be talking about. But not only did we see it in the cameras, but I could see it with the naked eye. I mean, as soon as I walked up to the camera, when we had to hit the button to start the timer again, I looked up and said, oh, it's moved counterclockwise. But I thought it was gradual because there's 50 minutes where we don't even have to look at it. We were sitting in the car. It was freezing cold that night. And windy and all kind of stuff. Well, actually, by that time, I think the wind had died down, thank God. But early on, it was really bad. So we were sitting in the car trying to keep warm. Anyway, I just wanted to let you know how that all started, what we were expecting, because this is going to come up later, why we did certain things the way we did and why we should have done them differently as far as capturing. What we did was we did time lapses. What we should have done was individual photos and then merge them later. But we weren't expecting a sudden jump like that. We were expecting to catch us gradually. So that's the reason why we filmed it the way we did and what we were expecting.
Right. Okay. Now, just before we get too far ahead, and I want to be careful that I don't sound like I'm jumping in and talking over you, but just some questions or whatever that need to be addressed as we go along before we get too far ahead. So you were saying that you were looking at moon calc and you saw this rotation, so that you were expecting to film it. But bear in mind, what type of mounts were you using?
2 equatorial mounts and one standard mount.
Okay. Now, Mike, you might want to answer this question. What is an equatorial mount designed to do?
Am I muted now?
No, we can hear you.
Okay. The equatorial mount will follow the movement of the heavenly body as it passes over the Earth. It will follow it, just lockstep.
Right. And there's another aspect to it as well, because an alt-as mount will also do that. But what's the difference between an alt-as and an equatorial mount?
Well, a lot of different. The alt-as is just like it says. It adjusts. It tracks azimuth left to right, along with the celestial body, and altitude up and down as it goes. So it's going left to right, up and down, whereas the EQ mount is on one axis. The alt-as is on 2 axes, and so they track differently. The EQ mount's one axis, and it will just basically spin in a circle, following whatever celestial object you aim it at.
Right. Well, we're on the right track for the answer there. You did a very good demonstration of something. I commented to you about this off air. What was that demonstration that you did?
Oh, about field rotation.
Exactly. So what does the equatorial mount do with regard to field rotation?
It should not show any field rotation whatsoever if it's properly aligned.
Right. And now this is my point, that Rich was looking at mooncalc.org, and he was looking at the predicted counter rotation of the moon. And that view that you're looking at in mooncalc is from an alt-as point of view, or from an observer's feet on the ground point of view. But you've both gone out and you've used equatorial mounts to film the moon. So would you expect to see any field rotation when using an equatorial mount?
Absolutely not.
Right.
And yeah, I do understand now. When he first called me, he just said, hey, I see something weird on mooncalc.org. It looks like a backwards rotation. And I didn't know what he was talking about, so we just went out and filmed him. But no, you won't get any field rotation with the EQ mount.
Right. Okay. So, Rich, any comments on that? Rich, you're muted at the moment.
Sorry.
Go ahead.
Yeah. In fact, before we did this, I did a video without specifically talking about what we were looking for, but that the shadow follows the moon wherever way it rotates. And of course, I got a million hates on it, but that was okay. I knew what I was looking for. But we did a hangout then. We had a flat Earth person, and we had a flat Earth person, Dave Marsh, who believes field rotation is real, perspective is real. And we had trying to remember his name, Crow XE, who was a globe Earth person on YouTube. They both agreed that an equatorial mount would show absolutely no field rotation. So that question was asked. I didn't know. I wasn't a camera expert by any means, and that was the answer I got from both sides.
Okay, so just to be clear, you now understand that an equatorial mount telescope will cancel out field rotation. Is that what you're saying?
Yes, well, I witnessed it did. At meridian crossing, when you get that rapid clockwise rotation, neither one of the equatorial mounts showed any rotation whatsoever.
Right, okay, very good. Okay, so with that, I think I'll share my screen again, and we'll look at some more images, which I've taken off one of Mike's videos, and present that to everyone. Okay, you seeing my screen?
I do.
Yes.
Okay. All right, so once again, these are the two mounts that we used on the night. Now, I understand that there was a third camera used, a Nikon B700, is that correct?
Correct. That was not equatorially mounted.
It was or wasn't, sorry?
Was not.
Was not, okay. And I see that you have sent those files to Mike as well. It would be quite good to be able to see those images or videos. What did you take, photos or time lapse?
That was just individual photos. And they were randomly spaced out about every 15, 20 minutes.
Okay, so they may not. And because they're on an old AS mount, they're probably really not going to be much good anyway. Agreed?
Yeah, everybody agreed that. I just wanted to see what the difference would be.
Okay.
Right. That's what I told you before, Dazza, that, yeah, I've got them on my computer. I can show them to you right now. But, you know, when you're just hand holding it and hand leveling it as the moon's going by, you know, what good are they?
Sure.
But I'm happy to share them.
Yeah, no, absolutely. I agree with you on that. So no problem. Okay, now, Mike, you uploaded a video explaining or basically answering my request to see the files. And my apologies, Rich, if I missed any video where you uploaded the video. But I was also looking to see the metadata for each clip, since I was aware that they were individual time-lapse clips. And so Mike uploaded this video, and I should make the point here too that I had also requested this data from Mike, but unfortunately, Mike, do you want to address quickly what happened there?
Which data? You were asking for Rich's original timestamp footage.
Yeah, and also yours. So I'm just
yeah.
Yeah.
Yes. Also mine. Yes. I do dozens of time lapses, and when I'm done, you know, 8-hour time lapse or 5 hours, 6 hours, whatever, I've got tons of files everywhere. And so it's always been my habit to, when I get done, I take all 8 files, I put them in a video converter, I merge them together and then make one file of it. And then I've just got, when I'm looking through my, my folder, you know, to find something that I'm looking for or whatever, instead of having 500 little thumbnails to look through, you know, I've got much less because I merged so many of them together. The problem is once you merge them together, once I merge them together, I delete the originals. I've got no reason to keep them. And well, up until this point, I never had any reason. And after this February 16th thing, I haven't had any reason to keep them either.
Right. So the original files off your camera were deleted, so we couldn't examine the metadata, which would give us the timings of when each time lapse was recorded, correct?
Correct. And I put them in the computer on the SD card, merged them, once the merge is done, I delete them right off the SD card. So unfortunately, they never even make it into my computer to where I could go find them in the recycle bin. So I know you asked about that, but yeah, they don't even come into the computer, just to the program to merge them, and then they're just deleted directly off the SD card.
Right. Now, this is a key point, of course, because we're looking at your footage showing an apparent sudden rotation and Rich's footage showing an apparent sudden rotation, and we need to be able to see if the rotation happened at the same time, and that's why that metadata was quite important. So on screen, I've got screenshots here from the video that you uploaded answering my request for that data. So we can see that this is from the P900, and these are the individual little time-lapse video files off the P900.
Hey,
sorry?
Hey, sorry to interrupt. Just so you know, I did find that rich merge. So anytime you want to see it, I can share. So carry on.
Great, thank you. All right, so we've got the individual files there, and Mike goes along and he points out each one. He shows the duration here, pointing at the video. We can see that that one is 8 seconds long. The maximum time for the time lapse, this is the end video, is 10 seconds, which, as Mike said in his video, let me just quote you there. He said, if it's short like this one is 8 seconds, basically it's 5 minutes of real time for every 1 second of time lapse. Now that's a very key point in this analysis. For every 1 second of the final video that we see represents 5 minutes of real time. Now, I should put a caveat on that. 1 second of video could actually represent less than 5 minutes. So we're talking about from 1 to 5 minutes. Would you agree with that, Mike?
Yeah, no, I did say when I made the video, approximate. But 1 minute, I do not think so. I don't know. I'd have to think about that.
Well, I'll come back to that because we can see an example here, and I'll show you that. So you said if it's short like this one is 8 seconds, basically it's 5 minutes of real time for every 1 second of time lapse. So you can approximate that this one started 40 minutes before the time is going to show on here, okay? So what you're saying there is because it's 8 seconds long, the final video, 8 seconds times 5, 8 times 5 is 40, we can assume that it started 40 minutes before the time that is shown, correct?
Approximately, yes.
Yeah, okay, so I'll step through to the next image where you show the properties. So here are the properties for the time-lapse video 0081, and we can see the modified time there is Saturday, February 16th, 2019 at 4:52:20 p.m. So that's the end time of the video. That's the time it was created. And so we have to take 50 minutes off that time, or 40 minutes rather, because it's an 8 second, 40 minutes off that time to get the start time. Is that correct, Mike?
Yeah, again, approximately, yes. Are you still showing the first one, the 8 second one?
Yes, I am.
I can't. Okay, I can't see. I'm looking on my phone and I can't see. All right, okay. Go on.
So there's that one. So it will, and we step through. So he shows the duration on each one and the properties on each one, which was quite good. So that one's 10 seconds. Let me just check the duration of the previous one. So the second one was 10 seconds. The third one was 10 seconds. The fourth one is 8 seconds. The fifth one is 3 seconds. And the sixth one is 3 seconds. Sorry, I'm up to 7 now. 1, 2, 3, 4, 5, 6. Yep. And 10 seconds, 10 seconds, 10 seconds. Now this is 1 second. Okay. This one is 1 second. So if we say, well, 1 second of video is 5 minutes, then that would be 5 minutes of video. But what we can see from the properties of this one and the following one, this one here, let me just show you that. This one ended at 10:27:14, 10:27 p.m. and 14 seconds. And then the next one ended at, it must be the previous one I'm looking for, 10:27:02. So there's a difference in time between these two of only 12 seconds, but it comes up as a 1 second video. You follow what I'm saying there, Mike?
Yeah, I follow what you're saying. It seems you're making a little bit of a mountain out of a molehill, but carry on.
No, I'm just trying to make the point that we're covering the details so that people can follow exactly what we're doing. So I'm not saying that 1 second is necessarily 5 minutes, because in this case it's actually only 12 seconds. All right, so let's go back to the main view there of the files. Now, is there a problem, and I know that you've actually covered this in your video where you went through your messages on Google Plus with Rich. Is there a problem that we see here that you need to point out at this stage, either Mike or Rich?
I'm not sure what you're asking.
We can see the video files here from 0081 through to 0092. Is there a problem that we see on screen here with these video files? As I say, I know you've covered this, but we need to paint the whole picture for people listening so that they follow what's going on.
Well, I would defer to Mike if there's a problem with them, because he's more of the camera expert than I am.
Okay, I do know that you commented on this, Rich, and
I was talking. I'm sorry, but I was talking and I was muted. He's talking about your file 85, I think, Rich.
Exactly.
Oh, okay, yeah. File 85, for whatever reason, was an audio file.
It was an audio file. Did you listen to it, or how do you know that it was an audio file, given that it was filmed on your P900?
Yes, I tried to open it as a. I don't know how it happened, but it was an audio file. It would not open as a video, and I could hear like wind or whatever.
Okay. So possibly, maybe instead of doing a time lapse which has no audio, do you think it's possible that you started filming a short video by accident, maybe?
Well, like I said, it did not show as an audio file, so I don't know.
Okay. All right. So we can only speculate on that at this stage, and I'll come back to that. So there's a key point that we have to make here, is that we don't have a complete series of videos. We've got 81, 82, 83, 84, 85 is missing, 86, 87, 88, 89, 90, 91, 92. Okay. So we've been through those and we've looked at the properties on each of those and the duration. And then the next part in Mike's video is he's pointing out the sea of crises there at the top. This is on video file 84, and he's making the point, you know, look at where it is on this one, and at the end of video 84, and look at where it is at the beginning of 86. And of course, there is no 85. Okay, are we happy with that so far, guys?
Yep.
All right. So here is a breakdown of each one of those files. So we've got the file number on the left. We've got the duration of each final time-lapse video file there. And in brackets, the approximation of time, given that for every 1 second of the final video is up to 5 minutes of video, okay? So as we said, 8 seconds of video is 40, 10 seconds is 50 minutes. And using the properties, we can see the end time exactly down to the second for each video file. And as Mike pointed out in his video, that if we subtract the duration time from the end time, will give us the approximate start time. Are you agreed on that, Mike?
Yes, sir.
Okay, so I'm going to start from the bottom up. This one finished at 11:09 p.m. and 20 seconds. This was the last video file, which finished recording at 11:09 p.m. and 20 seconds, minus approximately 40 minutes, because it was an 8-second duration. That takes us to 10:29 p.m. Okay, well, we've got a very slight discrepancy, but it's pretty close. So as you can see, we've got these color-coded, so each one relates to the previous one. I've put some arrows in there to make it easier to understand. All right. Now, this is the one that was only 12 seconds long because the camera was, there was one video that was 50 minutes long, which finished at 10:27 p.m. And then the next one finished at 10:27 and 14 seconds. So there's a difference of only 12 seconds there. But that shows up as a 1 second duration time-lapse video. And that was the point that I was making before, that 1 second could be, you know, anything from 0 to 5 minutes. And this is actually a good case in point. All right.
Well, no, not necessarily, because you could see when I did that video and I clicked on that little one and I said, what you see is what you get. That's all it was. Now, do you think that one little quick shot could be 5 minutes? On the other hand, when you look at the other time lapses where it was only 8 seconds and you watch it play through, now do you think it was really 1 minute? You see what I'm saying? So you can use some common sense and say the 8-second one has the moon going through a whole bunch of crap, and the 1 second one is just a single shot. So we got to use discernment.
Yeah, and I'm absolutely in agreement with you on that, Mike. I'm not sure if you're possibly misunderstanding what I'm saying. I'm actually making that point myself as well. The little 12-second clip is just, you know, you see the moon. As you see, that's all you've got. So it obviously wasn't a long time lapse. So I hope that we're in agreement on that.
Yes, we are in agreement that no one would get confused and think that was a full 5 minutes.
Sure. Okay. So there's the breakdown there. And now we're sort of really getting into the analysis here because I've put a gap in there because obviously we've got a number 84 video missing there. And once again, the arrows there, just so make it easier to follow what's going on. And this is really the point that we're getting to now, is that we've got this missing video, which for whatever reason, there was some sort of foul up, whether it was an audio file or other video or whatever. But the point is that we've got a break from between, well, 86, which was a 3-second duration time lapse, so that could be up to 15 minutes. That one ended at 7:41, and if we minus 15 minutes from that, we get 7:26 p.m. I think that's how you calculated it as well, Mike. Is that correct?
That's how I calculated it, yes.
Okay, so you're happy with 7:26, and
I got no reason to come up with any other number, so I guess I'm settling with 7:26 because what else can I do?
Right, and then the previous video, number 84, ended at 7:19 and 34 seconds. So we've got a time somewhere between 7:19 p.m. and 34 seconds and 7:26. So we've got a period of 7 minutes there. Would you agree with that, Mike and Rich?
Yeah, well, you keep saying the same thing about 3 times. We agree.
Yep. Okay. Yeah. Very good. I just want to make sure I'm not, you know,
agreed,
painting the wrong picture or anything like that. I don't want to be unfair at all. So
no, our theory has been from the start that the jump happened within a 7-minute window between 7:19 and 7:26. That's been our claim from the beginning.
And that's not just from this file. That is also overlaying Mike's timestamps on his.
Okay, we're going to come to that as well.
Okay.
So the lunar leap, the alleged lunar leap, apparently occurred between 7:19 and 7:26 p.m. But unfortunately, we've got no actual video of it because, as we see in the videos, there is a sudden rotation, and there's also a leap. And I think maybe I will pull up the video on that. Where are we? Just bear with me. Okay, that's a short version, so let me try that one. Okay, so Rich didn't mess with the zoom, and so I'll just play the audio on this.
To Mike Boll's video answering Lunar Leap questions part 2. This is the detailed photo analysis. Now, towards the end of Mike's video, he plays a clip from Rich's video, Mr. Thrive and Survive, and he makes a statement that Rich didn't mess with the zoom. Well, indeed, we see that the zoom isn't changing, but let's take a look. So here is the moon bouncing all around, as we saw before, but at least it's not zooming in and out. And pre-jump, and here it comes, bang. Mike, why did the moon suddenly jump up in the air like that?
Okay, I'll just pause it there. So the point there is that with that sudden leap upwards that we see, obviously we don't have a continuous video from the pre-jump to the post-jump point. Would you agree with that? This is within that 7-minute period.
Absolutely, yep. There's no secret there. We've been saying that from the beginning. So yes.
All right, so I'll carry on.
Hey, maybe the moon not only suddenly rotated, but also suddenly jumped sideways in space.
My apologies for my humor.
Well,
okay, so now we look at both time lapses side by side, yet we've got no timestamps to verify the continuity or the synchronicity of the two videos. And here it comes in 3, 2, 1, jump. There is the jump. He plays it back a little bit slower, so we can see the rotation of Mike's and Rich's video. There it is. They both rotate to the left there. And finally, he plays it again very slow for us. And there it is, the rotation. Now, I'm just going to loop that last bit a few times so that we can clearly see the rotation and the jump that we see there. So as we watch this replay of the rotation, not only do we see on the right that Mike's moon is jumping backwards and forwards, we also see that Rich's moon is jumping up and down, so clearly not continuous footage from either. But wait, there's more. Let's take a look at the images in more detail from Mike's video.
Before you go on, Mike's moon isn't jumping. He just changed the zoom.
Yeah, we understand that. And he explained that in his videos as well, that he stopped the time lapse and zoomed.
Yes, that's correct. Go ahead.
And can I say something too?
Yeah, go ahead.
Go back through the time lapse and you'll see the Rich's moon and my moon are jumping up and down all throughout. That's what happens when you don't have your EQ mount exactly polar aligned, that the moon will slowly drift off. Now, the thing that's people got to understand is when you're watching this time lapse back, you're watching 30-second time lapse, that's 3 hours of footage. So in that 3 hours, if I was shooting video, you wouldn't even notice it. But because we're shooting time lapse, the moon slowly drifting down to the left or up to the right or off to the side. And then we go take a break because you're not sitting there watching every shot. We come back and realize, oh, crap, the moon's off to the top left. Then you hurry up and adjust it back to the middle. And then the next 10-second snap happens. So in the playback, it looks like the moon's jumping all over. But what I'm trying to point out is you're trying to make a case of, look how Rich's moon jumped right here at the rotation. Well, go back through his video. It jumps 100 times. Right. So does mine. So, okay.
And I'd like to add something to that too. You can have a perfect polar alignment and still have this happen because the drive itself does not know the speed of the moon that night, which is variable.
Okay. Astronomy Live, would you like to comment on that?
Well, you can set the speed of the drive to match the speed of the moon. In fact, if you track at a sidereal rate, you will have the moon drift out of the view relatively rapidly in any given time lapse. But I did a time lapse over 4 hours long where it wasn't drifting out of the view at that rate because I had set it to the lunar rate, the rate that the moon was moving through the sky.
Now, was that a preset thing on there, or is it set by the date and time that you're doing this?
Well, neither. You can directly set the drive rate. You can set it for sidereal time, which is a 60 hertz setting on the quartz clock of the telescope, and then you can change that frequency, which an average lunar rate is about 57.9 hertz.
Okay,
so
we're not using a telescope, first of all.
Well, yeah,
well, you're using an equatorial mount, which
yes,
but that's what's driving that. It's not about the optic; it's about the
mount. There is a setting that says for the moon, but it doesn't know if the moon is fast, slow, or its average speed that particular night.
Okay, but all right. In my example video, it is set at the average speed. It's not. I don't set it to the exact speed of the moon that night, but an average speed will do a good job of allowing it to track the moon much more accurately than a sidereal rate. And in my time lapse, you don't see that kind of rapid jumping around, at least not from the equatorial aligned scope.
Okay, can I butt in here? You're also aligning yours with Polaris. A lot of the stuff we're shooting is the daytime. So we're guesstimating, okay, here's north. Here's 33 degrees altitude. This is about where it's going to be. Let's start that sucker running. And as she starts to track off, we'll continually adjust it and hope, we get something good, because we're starting off in the daytime. That's one thing. But the point Rich is also making on the larger sky watcher that I've got, the white and green mount, the Astro Tracker. I've got the sidereal, I've got the sun speed, I've got the moon setting. What he's saying is when I do set it on moon, okay, so now I've got this place. I don't know if you've seen in my videos where I've got a couple of those EQ wedges just mounted to my balcony now. So I don't have to bring a tripod out, try to guess where's north and all that. They're already set. I can just slap the tracker on them.
Mike, I'm showing on screen for you.
Huh?
I'm showing them on screen for you, by the way.
Oh, yeah. So yeah, I can just, they're just mounted. So now I can just walk out. Now that, the first one there was with a tripod, but anyway, so I can slap it on there and start tracking. So just for the last week, it's been perfect timing. I've been able to get home from work and the moon's just rising. And the first 3.5, 4 hours, that thing will just track perfectly. No adjustments whatsoever. After the moon gets to a certain altitude, it will track differently. And that's what Rich is talking about. So I've got it set on the only speed I can set it on, which is, well, not the only speed I can, but I've got it at the moon speed. That is the only one I can put it on. I can just put it on moon. And then I'm learning little by little since I moved in here and got these things mounted, that as it gets to a certain altitude, I've got to switch it to sun and it'll track better. And when it gets real high, I've got to switch it to sidereal sometimes, and it'll track the moon perfectly. Then as it starts coming down the other side, I've got to go back to sun for a while. And then when it gets close to the horizon, I've got to go back to moon for a while. So that's what Rich is pointing at is the moon in one night passing over us does not go at a steady speed.
Okay.
Well, sorry, Daz, did you want to?
Astronomy Live has pointed out that he has tracked the moon over a period of hours, and
so have I. I just pointed out that I did. I can show you one right now on my computer that the first 4 hours didn't have to touch the thing at all.
Yeah.
Matter of fact, I sent a text to Rich after I shot that one. That first, I think it was my second day living here, and I said, "Oh my God, I'm getting it zeroed in." And then I said, "I haven't touched that thing in 3 or 4 hours, and it's still just dead center."
Yeah.
So it can be done.
There's some nights where you can get it perfectly, and I think it's full moon.
Yeah.
For a long time. But if you even just go back to that mooncalc.org and just scroll through the hours, it'll give you how fast the moon speed is over the Earth, and it varies very, very much throughout the night and each day.
Okay, and I think the main point that you were really making before too was that the fact that it's a time lapse where you've got 50 minutes condensed down to 10 seconds, and you're filming over hours, then it's going to make it look like the moon is bouncing all over the place, because it's
That
not
is the point. Yes,
Right.
that's the point. Thank you.
Yeah,
Well,
and the other
okay,
point, and the other point is, I don't want people to say it was a bad equatorial mount, because it wasn't. Because at meridian crossing, neither one of those cameras picked up any rotation whatsoever.
Yeah, and the issue is not actually going to be the equatorial mount. I can tell you that already, Rich. So
Okay, well, I just wanted to clarify. That's all.
yeah, and I've just pulled up Moon Calc. I don't want to get too bogged down at this stage.
I do want to point out, though, that there
Yeah.
is one fundamental thing that I haven't seen done on your mounts that would affect the apparent rate of the moon as the mount goes through its tracking, and that is counterbalancing. I counterbalance my mount so that it's perfectly balanced for weight based on the payload that I've loaded onto it, with guide scopes, with cameras, with all of this. And this allows for smooth tracking throughout the night. For 15 years, I've had this telescope, and I've never had an issue where the moon started suddenly tracking at a drastically different rate, and it ended up tracking at a sidereal rate. That would be rather extreme. Now, the moon will undergo variations in velocity through its orbit, and depending on whether it's near perigee or apogee, it will have a slightly different rate, but not to that extent. So
yeah, I hear you. That's a great point, and a great hint for me, because you think about counterbalances when you're talking about big telescopes, a lot of weight and all that, and you just don't think about it when it comes to a little DSLR camera. But you know what? Those suckers are heavy when you get that lens all the way extended. So that is a point well taken, and I think I will definitely look into that. And Daz also sent me a deal for a around the right before the lens mount that'll center it better too. So, but yeah, that's a great point. Thank you for that, because that might make a big difference. But yeah, today I shot since 2:30 this morning until, I don't know, 12:30 in the afternoon or something today. And I was using sidereal mount there for a while, or sidereal speed for a while to keep it going. But anyway, thank you for that point.
Okay, so I'll carry on with the video that I was playing before. Was the audio coming through okay when I was playing the video?
Yeah, it was coming through. It was the audio, the audio of the video you're playing, it was coming through. It's a little softer, but it was coming through.
Okay. If there's any problem with it when I'm playing it, please let me know.
The pre-jump comparison, and this one is the post-jump comparison. So again, switching between them, we can see the apparent rotation. So let's do a bit of analysis on this. And first of all, I'm going to use the magic wand to capture a copy of the moon on the left here. This is from Rich's image on the left. I'm going to copy that, and I'm going to paste it and drag it over to the right so we can compare it with Mike's image. Now let's stretch it out. I'm keeping the aspect the same by holding the shift key there. And we can see that the orientation is exactly the same. We can see this little crater on the side there, on the left-hand side, and we can see the Sea of Crisis up on the top there, the one that they always point out, is orientated exactly the same way in the pre-jump image. So what I'm saying is that Rich's image on the left agrees exactly with the orientation of Mike's image on the right. Now let's do the same thing with the post-jump image. So once again, I'm going to use the magic wand and select Rich's image on the left. I'm going to copy it, Control C. I'm going to paste it, Control V. I'm going to drag it over, and we're going to compare that with Mike's image on the right. Let's make it the same size. And we can see a problem here, because obviously the orientation is different. Remember that this is post-jump, and they should be showing exactly the same angle if the videos were synchronous. Obviously there is a problem here. Let's look at this again by flicking backwards and forwards between the two comparison images. Here with the blink test comparison, we can clearly see that the orientation is different. They should both agree.
Okay, guys, so I'll just pause it there and get your comments on that. Do you agree that we're seeing different rotation in the post-jump image?
Yes. One rotated counterclockwise 10 degrees, and one is approximately 20 degrees.
Okay, do you have any explanation for that?
I do. And a matter of fact, I made a little video, what I think might have happened. It's 5 minutes long. If you let me run it, then it'll just explain it all.
Sure thing. Okay, I'll stop presenting and you can share your screen. I'll present you.
Okay, so I got to figure out how to do this. Share screen.
Does it have audio?
Yes, it does.
Okay, so you may need to run the audio through your microphone as I'm doing. The computer audio does not feed through the Hangouts.
I might have to run it through the microphone. Okay, let me think what. Hold on. Let me get this up here. I can't even find the screen. So if you guys want to talk for a minute, okay, I got that on the screen now. I just got to get it to where I can share it with you.
Okay, so just while you're getting ready, so I'll just reiterate my point that we saw that with the pre-jump images, they were both in 100% agreement with each other. In the post image, we saw that there was a discrepancy. So hopefully Mike's video might be able to address that when he's ready.
Yeah. And would you agree? This is just for a point that I know will come up later. Would you agree that both of sea crises on both were pointing pretty much at 12 noon position?
Pre-jump or post-jump?
Pre-jump.
Yeah, slightly off. Hang on, let me take
more or less 12. I mean, I'm not saying exactly.
Yeah,
but
I think
more or less 12 up. Okay, it just because I know it'll come up later.
Yep, 12 o'clock. There we go. I'm happy with that. I'm looking. Oh, you're not seeing my screen, of course. I'm looking at it.
Yeah, that's cool.
Yep.
Okay, are you seeing my screen?
No.
Let's see.
He's sharing on his computer's account.
Yeah, computer account. Sorry. Thanks for that, Shawn. Let's see. I got to do it again, or okay, there we go. Let me do it again. And share.
Oh, okay. Yep. So let me present that.
All right. Let me put this down small. That was the rich merged one that you were asking for. Okay. Let's see. You said so I basically turned up my volume on the computer and let it come through the phone, since that's what I'm talking to you through.
Yep. Okay.
Okay. Now we got the echo though, huh? Damn it. I don't know how to do this. You know what? Let me just disconnect on my phone for now, I guess.
Yeah, sorry about that, people. Now, Shawn, you there, Shawn?
Yes, I am.
Okay, I just thought my Hangout had frozen up, but it seems to be okay.
Oh, I don't show Mike as sharing a screen anymore on the computer account, but hopefully he'll get that fixed in a second.
Yeah.
Okay. Okay. You got me now on audio, right?
Yep.
Okay. And my screen's on there, so let's see.
Oh, he just exited the window.
Okay, he's just dropped out, so hopefully he can join us. I'll send him a message on Skype.
It happens.
Yeah, it's his first time on Hangouts.
Yeah.
This is totally acceptable. I mean, he's new to Hangouts. He's got a little happy on clicking X's. It's not a big deal. He'll be back.
Yeah, we had a little test run earlier on, and it's his first run on it. So, okay, if you're in contact with him too, Rich, you might be able to help him out.
Yeah, I'll text him.
Yep. Okay. Okay. Well, hopefully he'll be back very soon. Meanwhile, I might just have to fill in. I'll carry on, I think, with what I was sharing before until Mike gets back. Yeah, which one am I looking at?
There he is.
Okay.
Can you hear me?
We can.
Yes.
All right, let me try this again. Let me get the, I want to get that out of there, don't I? Oh, I'm not, am I sharing the screen yet or not?
No.
No.
Okay, okay, there we go. Let me do this again, or try to here. Screen share, application window.
Just make sure your Hangout's not shared in that, please.
Yeah, that's what I'm trying to do here. Hold on. Now I got to get the freaking picture back up here. This is the first time I've ever even done this, so sorry, guys.
No,
Okay.
That's fine.
All right, so let's see. I'm gonna say, okay, there we go. Share. So you should be just seeing like a photo album folder or something.
Yes,
See it?
I can see that.
Oh,
You present it
all
to
right.
everyone now.
All right, so let's down to this thing here. There it is. Okay.
The P1000 has been tracking the moon.
Can you hear the audio?
Yes.
Okay, I'll let her go.
2:30 this morning. It's now about 7:30, so about 5 hours. It started off like over here in between the telephone poles, and then the EQ mount slowly followed the moon around to where it is now.
We're still just seeing the folder view at the moment.
Why we have a 10-degree discrepancy.
Oh, you are?
Yeah, we're not seeing the video, just the folder view.
Okay, all right. I'm sorry. I thought you were watching the video. I popped a video out of the folder, so I thought that would be shown. Okay, let me. I don't know why it wouldn't. So okay, okay. I got this open. I guess I gotta share something else here. Hold
Yeah, so
on.
just share. It'll, if you go back to your share screen option, it'll give you the option to share your video.
Okay. Application window, and it's just not coming up. I've got the video open, and all it's giving me is the option of Google Hangout screen, and that's what we don't want to. I don't know why that video is not coming up in.
Hey, Mike.
Are you using Windows Media Player?
I don't really know. Probably.
The other way you can do it,
That's
you can
probably
clear.
why. Because
I was just going to say, just clear the browser where it says hangouts.google.com and all the other stuff after it. Delete all that out of your browser, and then just share. And then just share, and then open it up. We should see what you see.
Okay, that's what I'll do. Thanks, Rich. All right, here we go. Okay, can you see now?
Yeah, now what you have to do is switch to that window.
Okay. So, okay, here we go. This now, can you see the video here? Got two cameras on it?
Not yet.
Really? It should be sharing the whole flipping screen.
yeah, it's the media player that you're using. It doesn't like DirectX with full Hangouts, so it's not going to allow you to show.
Okay, so let me go back to the.
For future reference, download VLC player. It's very, very compatible with Google Hangouts using share application.
Oh, I've got it on my phone. I don't think I have it on my computer. Let me see if I can play it with something else. Open with Windows Media Player, movies and TV. I guess I don't have VLC on here yet. Will either one of those work? Movies and TV, maybe?
No, movies and TV player still uses the same version of DirectX that media player uses, so it won't work.
That won't work.
So we might have to come back to that one maybe later if we can, or maybe you could post that video on your YouTube channel and we can share that.
Okay.
Would you like to talk us through it?
Well, it's more of a it's a visual, so no, but you know the basic long and the short of it. Hold on, just
Stop sharing.
What is the file size on that? Because it might be useful to either send that video to Rich or Astronomy Live, or Dazzler Cameron, who actually are set up to play it on VLC.
Yeah.
Yeah, what I was looking for, I was just going to download VLC right now.
Okay, I don't want to hold things up too long with technical issues.
Yeah. So, well, I understand that. But you know, it's got to be on the video. Basically, the gist of it is, Rich was gifted a camera at the Denver Flat Earth Conference, and when I first met him, he hadn't even taken a single picture with it. He didn't know anything about it. He didn't know, how they work or how to set them up. He didn't know anything about the mounts.
It's just the P900.
What's that?
It's just the P900.
Yeah, he was gifted that P900. Yes.
Right.
Yes. Okay. So on February 16th, it was only his second or third outing with me to do this kind of stuff.
Mm-hmm.
So we did the initial setup. I kind of walked him through there, and we, it was still daylight, so we guesstimated about where Polaris would be. He aimed his mount, I aimed my mount, and then he also had his B700 on the third mount. And sorry guys, he had his B700 on a third mount, and after we started it, I ran my camera, he ran his two cameras, and what I'm thinking is that instead of, when we came out, everybody knows that story, that we let the time lapses run down to 0. And came back out, realized that the cameras weren't taking any pictures, although the mounts were still tracking the moon fairly well. I mean, the moon had drifted off top right on his or top left on mine, whatever. So we both had to adjust before we hit the shutter again. And I zoomed mine back out and hit start. But I adjusted mine with a fine tuner. And I think Rich might have been, since he was adjusting his B700 with the ball head, loosening the ball head, moving it around. I think when that happened, it was kind of a stressful situation because we were all, we were kind of like, oh crap, man, we're not shooting any pictures.
Oh.
Yeah, so I think he might have adjusted his with the ball head. And let's see, hold on. I just downloaded that other one. Here we go.
I'll just stop you there, Mike. Just to clarify, are you saying that this happened at the point of the lunar leaf rotation?
Okay, hold on just a minute. I didn't hear that because I started playing this video. Okay, go ahead. What?
Just to be clear, are you saying that this was happening with Rich adjusting the ball mount at the point where we see the apparent lunar leaf rotation in his video? Is that what you're saying?
That's what I am. That's what I'm asserting. Yes, and for all I know, he was adjusting it that way the whole night. When it got off a little bit and we had to retract it. I do notice in his footage that the jumps are more, prominent than mine. So I don't know if he was fine tuning or if he just, was going for what he knew, loosened the ball head, moved, try to center the moon back into the viewfinder and, hit go again or whatever,
Right.
So that's what I'm thinking. I've got the video up on VLC now.
Okay.
Okay. So I wanted to show. Yeah. Let me just run it, man. It's 5 minutes. Can I?
Sure. Go ahead.
Can you see the VLC screen now?
No, not yet. I can see your Hangout screen. I'm going to present you to everyone. Is the Hangout link hidden?
Is the Hangout link what?
Is the Hangout link hidden?
Yeah. Check it, Mike, because it pops back in.
Yeah, let me check it. Okay, it's hidden. I'm going to share one more time and share everything. Okay, it says I'm screen sharing. Okay, you've got the Hangouts. I'm going to make that small. Okay, now can you see the video here?
Yes, we can.
Fantastic. Let me make it big and let it play.
P1000 has been tracking the moon since 2:30 this morning. It's now about 7:30, so about 5 hours. It started off like over here in between the telephone poles, and then the EQ mount slowly followed the moon around to where it is now. I think what happened, why we have a 10-degree discrepancy, I had a camera on an EQ mount. Rich had a camera on an EQ mount. Rich also had a camera just on a tripod, E700, that he was loosening the ball head. He'd take a picture, and then 15, 20 minutes later, he would move it to where the moon was, take another picture, and so on and so forth throughout the night, because he wanted to have one that wasn't on an EQ mount for comparison. And I think what happened when the time lapses stopped and we came back from the car and realized they were stopped, I think I did my normal fine adjustment on my camera and restarted mine. And I think Rich, since he was used to moving the BE700 all night, he might have, instead of just doing a fine adjustment with his EQ mount, he might have just inadvertently adjusted it that way and started his time lapse. And the ups and downs that this guy can give you, left to right, and up and down little micro adjustments, won't change the orientation of the patterns on the moon, but tipping it this way will. So I could change the orientation. Matter of fact, let me show you that. When I align the camera similar to the one that's been on a time lapse for a few hours, notice the orientation of the moon. Okay, so now notice the orientation of the moon once I set the camera up to a more level position from my point of view. Note that the light and dark pattern on the left camera is almost diagonal with respect to the viewfinder itself, and the one in the right camera is pretty much vertical with respect to the viewfinder. Now consider the position of the camera on the right. That's the one that's been tracking for a few hours. During normal EQ mount tracking, they get all upside down, cockeyed, and all different kind of positions. So if you were to bump the camera with the ball head gave way or whatever, or if you manually adjusted it, if you wanted to fix it again, you got to ask yourself, would I tend to set it more vertical with respect to my position, or would I take that already cockeyed camera and tip it even more upside down and recenter the moon? Because taking the camera on the right there at that cockeyed angle and readjusting it on the moon to a more natural position from where you're standing, like the one on the left, will always rotate the moon clockwise every single time. So in order to get a counterclockwise rotation, manually adjusting the ball head or whatever, you would have to take the one on the right and tip it even more upside down. Somebody at the Denver conference gifted Rich a P900. When I first met him, he had yet to even take a single picture with it. He didn't know how to work the camera. He didn't know about EQ mounts or any of the setup. And when we caught the lunar leap, it was only his second or third time out with me doing astrophotography. I honestly believe that the 20-degree rotation I caught with my camera was legit, and that Rich also caught the 20-degree rotation, but he adjusted his camera when the timer had stopped and we restarted him. Instead of adjusting it with the fine tuner, I think he adjusted it with the ball head, and in doing so, he straightened up the camera a little bit, 10 degrees worth. So when he hit this shutter button to start the new time lapse, even though it was a 20-degree jump, his camera reflects it as 10 degrees because he had already straightened up the camera the other 10 degrees. Okay, thank you.
Okay, thank you, Mike, for presenting that. So just to recap, what you're saying is that you believe that Rich adjusted his camera by basically 10 degrees, which took 10 degrees off the 20-degree rotation, and that you both, in fact, still filmed this rotation, but that is why there is a discrepancy in the apparent rotation. Is that correct?
That's the fact, Jack. That's what I'm claiming. Yes.
Alrighty. Okay. I'll carry on with my basically the final part of my presentation now. So I'll stop presenting you. And I'll share my screen. Okay, so back to right window there. Back to the images that we were looking at. And this final analysis here. Rich, do you know how long the battery will last in your P900 on a full charge? Thank you, P&K Space Imaging. Appreciate it.
I do not, but that was not relevant that night because we were using external power.
External power on the P900?
Isn't that what we were doing, Mike?
No.
Yes.
Mike,
Yep.
how was the P900 powered?
Externally. Can you hear me?
Yeah, I can hear you.
Yeah. Yeah, they were both powered externally. I have a converter in my car and ran the extension cords out. Both cameras were plugged into electricity.
That's a fact.
Okay, well, maybe I'm wrong, and maybe there's something that I need to learn about the P900, but as far as I'm aware, you can't charge the camera while it's actually been running.
No, but you can run it direct on electricity for hours and hours and hours. You've got to have the battery in it. The battery's got to be in there, but once you plug in the power to it, like you would if you wanted to charge it and turn it on, then it'll just run for hours.
Okay, so basically you're saying that you've got a power lead going into the USB jack on the P900 to power it?
Yeah, you got it.
Yes, it's a converter. If I just did a quick search, you can see videos on YouTube on how to do it as well with the converter.
Okay. Well, that's something I wasn't aware of, and it's something I'll have to look into.
Yeah, you got to have your battery in there, and it's got to have a charge. But just go ahead and plug the power in with it. Let it run. It'll go on for hours.
So, in part of my analysis, the battery time is certainly a factor, but it's not the final part of the analysis, as we'll see shortly anyway. And I think I'm not presenting to everyone, am I? It's chopping in and out. Let me just change that. Here we go. So I found it interesting that the place where the video was missing, video number 85, which Rich deleted because he said it was an audio file or there was something file about it. If we look at the first set there of videos, so we've got approximately 40 minutes, then 50 minutes, and then 50 minutes, and then 40 minutes. So 50 minutes and 50 minutes is 100 minutes. 40 minutes and 40 minutes is 80 minutes. So 180, that's 180 minutes, which is 3 hours. And that is approximately what you will get on a fully charged battery on a P900. So part of my theory was, and as you guys have stated, Mike, in your videos, you explained how you and Rich were sitting in your cars. Earlier in this Hangout, you mentioned that it was very, very cold. So you were sitting in your cars, and at one stage as well, you were also messaging Rich, and you sent him some information online. And correct. So you also made the point that what you had been doing was to set a reminder by using Google to remind you to set the next time lapse when the 50 minutes ran out, correct?
Correct.
Okay. And you said that you had forgotten to set the reminder, and this actually occurred during this 7-minute missing period from 7:19 to 7:26. Agreed?
Yep.
And it seems to me to be a remarkable coincidence that was pretty much exactly 180 minutes from when you started the video. But what you're telling me is that you were using external power into the P900.
There's absolutely no doubt.
And not only that, but the P1000, it's nothing like the P900. You can maybe get 1.5 time lapses out of a battery on that sucker, and it's dead. But the way I've been doing it at my house, I hook it up electricity and I'll let it go all night, 12 hours. It'll never die.
Right. Okay. So I'll take you on your word on that, because it's not actually the final important puzzle piece, if you like, in
Okay.
the analysis. Okay, but you'll notice that further on down we see where we've got 2 minutes missing later on. That also happens to be approximately 180 minutes. It's 185 minutes, in fact, when we see that there is 2 minutes missing. So my theory was, and I still feel that this is relevant regardless of whether it was because the battery went flat or because it was that you guys had forgotten to set a reminder to set the next time lapse, and then suddenly you had an oh crap moment, and it was panic stations to get things sorted out. So my theory was that you had changed the battery out in the bottom of the camera, which of course means removing it from the base of the camera, and that there would be some rotation. But I hear what you're telling me is that you're using external power, so that would mean that that theory of suddenly removing the battery and knocking the camera, rotating it, would not be correct. We agreed on that?
Well, yeah, we're agreed on that. And yeah, I'm sure you've removed your batteries from there. You can slap that thing out of there and back in with a little bit of shake, but no, you know, it's not just going to bust off the ball head because of that. And remember, the ball head was still tracking the moon on the EQ mount. So,
Right.
but no, they were direct wired anyway. So yeah.
Okay, so I'm going to share a couple of videos that I've put together, very short videos. VLC, once that comes up for me, here we go. So this is the video that I reconstituted from your video, Mike, where you showed the video clips. Now,
okay.
It won't be as perfect as using the raw video files, because I'm relying on seeing when you push the play button and working out when it stopped from the end of the motion. It also helped that towards the end of it, when you were playing each clip, you were actually pounding on your keyboard, spacebar or whatever, quite hard, and I could actually hear you starting it. So there is the jump on Rich's footage at exactly the 35-minute mark. Now, Mike, can you tell me at what point, how many seconds into your video the lunar leap occurred?
No, I can tell you that Rich's time lapses were missing time. And like I said, he was getting used to the camera. He was probably hitting some stuff that he shouldn't, like when he was adjusting it as the moon was drifting off. You know, you know how you can stop a time lapse, right? You just hit that OK button in the middle of the wheel. You know, maybe he was grabbing the camera there and stopping it, because otherwise, why would his first one be 8 seconds when we first started, and then the couple of them were only 3 seconds? So he was obviously turning the time lapse off and on. You know, like I said, he was new at it, but he wanted to do his own thing, and that's how it happened. But no, they don't line up. When I lined our lunar jumps up together, so they happen at the same time, I had to physically minus some of my beginning footage to account for his 3 seconds.
Right,
So,
and I'm also going to come to that because I've done the same thing. So we'll look at that in just a moment. But I just want to be clear on a point, because you actually did talk to Rich about this, and it was shown in your messages in the video that you posted, where you were talking about the lunar leap and at what point it occurred in your video. Can you tell me at how many seconds into your time-lapse video that the lunar leap occurred?
I cannot.
Maybe you've forgotten. You stated it was 42 seconds.
Oh, okay. Oh, yeah. Yes, I said have the text. It said, tell me you caught that leap at 42 seconds or whatever. Yes. 42
seconds. Okay, so I've just played Rich's video, and we can see that the rotation occurred at 35 seconds. Now, you've pointed out that the two videos, your video and Rich's, do not synchronize because Rich was stopping the camera and so forth, all right? So that brings me to the next video that I will play, and this is the videos from the start. So these are, I synced them up from the start. Where is it? We see some clouds coming into view. Here we go. So you can see that the clouds there are the same, okay? So we've got Mike's video up here in the top right, and we've got Rich's video down here in the bottom left, and we can see that the clouds actually match. Agreed?
Agreed, and the jump's not going to happen at the same time because there's some footage missing in his. So
exactly. So let's just see what happens. It's all pretty good for a while there, and then after a while, here we go. It's now out of sync, so that's not going to work for us there. No. So in Rich's video, remember that the jump occurs at exactly 35 seconds.
Hey, stop it there, Daz. Stop it there. Okay, now you see I'm still in blue sky.
Yeah.
Rich is already in black.
Exactly.
That's because some of his blue sky footage is just not there. So yeah, they're not going to sync up.
Absolutely. Okay. I totally agree with you, Mike, on that. So I'll carry on. Remember, it's at exactly 35 seconds that we see the jump or lunar leap. Here we go. 3, 1, go. There's the leap there. But of course, it doesn't happen later until 42 seconds into Mike's video, and there is the jump there. So because these two videos are not synchronized here, then obviously we can't use those either. So let's go to video number 2, where I've actually synced them up at the last possible point that we could, which, as I recall, is about 23 seconds into this video. So I will pause it there so we can look at the clouds, and then I will play it on. So 20, 21, 22. Okay, so here, let me just step through because it's not exactly frame accurate in the editing. Hopefully we can see some clouds if I haven't gone. There we go. So we can see that the clouds are matching up there. Do we agree?
Yeah, pretty close.
Yeah.
I don't see how this is going to be any different from playing it from the other spot, but go on.
Okay. So this is at 19 seconds into Rich's video, and I've got them synchronized at this stage. And let's see what happens. 22. Remember that the apparent leap is at 35 seconds. 3, 2, 1, leap. Okay, so there's the rotation there, and it hasn't happened in Mike's video yet. If we keep watching Mike's video, we will see the leap occurs in 3.5 seconds from this point. So I'm going to play it now. 1, 2, 3, leap. There it is. Okay. So we've got a discrepancy of 3.5 seconds on this one. And what did 1 second of video equal, Mike? Approximately?
About 5 minutes.
About 5 minutes. So if we've got 3 seconds, in fact 3.5 seconds, because I worked it out based on the frames at 25 frames per second, we've got 3.5 seconds. So we've got a full 3 seconds plus some. 3 seconds would equal how many minutes?
17.5. 15 for 3 seconds. 3.5, 17.5 minutes.
Right. So we've got a time difference between the leap that Rich apparently saw at 35 seconds and the leap that you saw, which is what, 38.5 seconds there.
You can't make that comparison because of the missing file.
Of course he can't, and I don't even know where he's going with this because. So what, Daza, let me just ask you this. What is your theory then, since we've got this 17-minute discrepancy? What is your theory that Rich rotated his ball head at one point, 17 seconds later, I rotated mine, and there we got it?
Well, there's certainly rotation on the camera, and as we saw in my earlier videos, and let me just pull up one of those very quickly. Where are we? Just be with me. Here we go.
Do you agree with that video I put on there that the only way you're going to get the rotation is by loosening the ball head and really tipping that camera left to right? You're not going to get it from what you're showing now, what I showed, that little slick adjuster's never going to do it. Go ahead. I'll let you finish your presentation. I just want you to, you agree that tipping it left to right, you can change the orientation of the moon?
This sort of movement is not going to change the orientation of the moon, as far as I can tell, but certainly any movement on that ball joint. This movement here was because of the fact that you're not using counterweights and just the way that it's set up, okay? But whatever caused the rotation, Mike, and I have to be perfectly frank here, what we're seeing in this analysis is that we've got a missing video, we've got a missing 7 minutes at least of time.
Yep.
when we compare the pre-jump and post-jump images, we see that there is a discrepancy of 10 degrees in rotation when they should actually be matching, which has meant that you've had to, find a reason for the discrepancy, and you've come up with a theory that maybe Rich had adjusted his ball joint. So you're theorizing or making assumptions or assertions just as much as I am in that regard. Okay. But I guess in the final analysis, Mike, is what I'm saying is that you guys have presented what you believe is evidence of a sudden lunar leap, but unfortunately, the evidence that you present is not consistent. It doesn't agree with each other. You can't show synchronized video, and you can't even show consistent amount of rotation. You admit that the rotation is different by 10 degrees in both images.
Absolutely. I admit they're not synchronized. I admit that the rotation amount is different. Yes, absolutely. And I admit from the very beginning that our amateur video that we took out there that night is never going to stand up to peer review to where I get a Nobel Prize because I've showed the moon rotates backwards. Our video will never do that. Nor will any of the other 4 or 5 videos that are out on YouTube that show the similar things. They will not stand up to peer review because nobody was over their shoulder filming them while they were filming the moon either.
Right. So, well, while you and Rich were actually out filming the moon, my good friends over at P&K Space Imaging, and this is a shout out for them. If anybody's not familiar with their channel, you might like to go over to P&K Space Imaging and subscribe to their channel, because they do excellent live feeds of the moon and the planets and so forth with incredible equipment. And they were actually live streaming the moon on February 16th, 2019, while you and Rich were actually doing your time-lapse videos. Their video is real time, it's not time-lapse. And I'll play a little bit of the video there. Unfortunately, and I was so thrilled when I saw that the guys had been live streaming the moon at exactly the same time. But unfortunately, they rotate the camera. So that threw the spanner in the works for me. But let's have a look at the video, and I'll play a bit of the audio as well, just so we can hear what they're talking about.
Don't discount the humans being there. No. We're going to be in Mars. We're going to go to Mars. If Elon Musk says so, then we're going to be there. I'd rather go to the moon first. Yeah. Yeah. We talked about that before. Yeah. And it makes more sense to go to the moon first than other places, because we may have to build our spaceships to go to Mars. And it's unexplored for the most part. Yeah.
You saw the rotation there? And
I saw the rotation. I also saw they don't have a perfect equatorial mount if we're going to be judged by the same thing. But go ahead.
Yeah, and I'll just play that on because you see that it rotates back as well in a minute. So, yeah.
Yeah, back it up one more time just for that last rotation, if you don't mind, Dezza. Just a hair.
Don't discount the humans being there.
No. We're going to be in Mars. We're going to go to Mars. If Elon Musk says so, then we're going to be there.
I'd rather go to the moon first.
Yeah. Yeah.
We talked about that.
Yeah. And it makes more sense to go to the moon first than other places, because we may have to build our spaceships to go to Mars.
And it's unexplored for
Okay, thank you.
Yeah. The moon is mostly composed like the Earth, and that was the biggest thing. We've talked about this too. That's the biggest thing, that the problem with the moon is that, if it was born from an impact with a Mars-sized type impactor hitting an early Earth, then the composition of the moon should consist of some of the composition of the impactor, Mars-sized object, that is, and the Earth. But it seems like it's composed mostly of like the Earth, like we know the Earth. So it's like, how could it be then? Well, one of the theories I have is that maybe at that point of that impact, our entire planet was rendered molten.
I wonder how shocked these guys are going to be when they realize that we can't go to the moon. We never been to the moon. They're telling, yeah, we need to go to the moon again before we go to Mars. Well, keep on dreaming, buddy, because they've been telling us. They've been telling us that we've been going there for 10 years, and now it's pushed back another 5 years. And
well,
anyway,
let me interject. I find it utterly fascinating that they rotated the camera at the exact time we caught the lunar leap.
It's all a conspiracy, Rich, isn't it?
It must be.
Hey, so I've muted the audio there, but just playing it on, you can see those fantastic images, and that they rotate the camera multiple times, which they do when they're filming the moon and other objects. But as I say, you know, I was just so gutted when I saw that rotation there. And by the way, I should point out that the time up left-hand corner is EST, so it's 2 hours ahead of your time, I believe, or 3 hours.
Depends what time of year.
yeah. So this was February 16th. So I think the time difference was 2
hours. Right. So that was the exact time, around 9:17 to 9:20.
Yeah. So
yeah, isn't that amazing? Isn't that amazing?
I actually talked to Keith. He's one of my Facebook friends there. Keith is the K in P&K Space Imaging, and we looked at this together. And so yeah, it would be maybe good to get Keith and Mark into a hangout sometime to look at some of this stuff. I guess you're looking at a different, I don't know, just changing things around there. So I'll pause that. So once again, a shout out for P&K Space Imaging. If you're not subscribed, you might want to go and check out their channel and hit the subscribe button there. They've got some great live streams there. So
would you guys mind if I ask one question? It's a little out of turn, but I think it needs to be addressed.
Sure.
Now, Mike made the claim that the discrepancy in the rotations was because Rich was messing with the ball mount. But I'm still waiting for Rich to either verify or deny that claim.
I honestly don't know. I was new to it, so I don't know.
Nor do I.
It's possible. It's definitely possible. I mean, until the conversation afterwards, I didn't know the difference between the fine adjustment and the ball, that it would make a difference. So it's possible. I don't know if it's likely or not likely, but it's possible.
My point with that was that I had done already a bunch of time lapses, so I knew not to mess with the ball head. I knew to do the fine adjustment. So if it was there in mine, you know, I can't imagine in a million years why I would just go grab my ball head and change the orientation of the camera on mine. So the fact that Rich's shows a little bit less, that's the only thing I can come up with. But like I said, none of it really matters. Yeah. I mean, we can't say, hey, this is proof.
Yeah, like I said at the
well, I just
beginning,
had the line of thinking that. Sorry, I had the line of thinking that, you know, if you're going to make a claim about what Rich did or did not do, why not just ask him directly if he remembers doing that? And, you know, now that that's I'll go back on the sidelines.
Okay, well, if you go back and listen to the video again, maybe I'll put it up on YouTube. You'll see I didn't make a claim. I told you that was my thoughts. I think what happened was Rich did this. That's how I put it. So I didn't claim that Rich absolutely revolved his camera exactly 10 degrees, and therefore everything's hunky-dory, works down to the gnat's ass. All right.
Now if we can leave,
what happened.
If we can leave cameras for a minute, I think you shared the text. We were going back and forth, and you made the joke about getting you a coffee, Mike.
Yes.
There was a Dunkin' Donuts nearby. That's coffee here, and they were closing at 7 o'clock, and it was about 8 minutes till, but it was only a couple minutes away. So I decided to go get a coffee. I asked Mike if he wanted one. He said no. So I went there, got it. They were closing. Came back. It was about 7:10 or 7:11, I think it was, when you texted me. When he saw my card pulling up, he texted me saying, "I'll take one," just as a joke, because he knew I was back. I got out of the car, and when I went, every time I got out of the car or went to get in my car, I looked up at the moon as a fourth witness, and that Sea of Crisis was at 12 noon. At 7:20 7:20, whatever it was, 7:21, which was 10 minutes after I got back with the coffee. When we got out of the car, I looked up at the moon and said, oh, it looks like it has been rotating counterclockwise.
And I will verify. He said that to me, but my eyes are just, they're crap. I can barely even make out the Sea of Crises, you know, with the naked eye. And I just said, well, whatever. Yeah, but he did. He definitely said that thing has rotated.
Okay,
But I thought it was a gradual thing.
right. Now, Rich, so you're looking at the moon with your eyes. So from that perspective, it's an alt-as view, not equatorial. What was the starting time? What was the starting time?
It's 20 minutes difference from when I looked at it, when I left to get the coffee, to when I came back.
And when did you come back? What time?
7:11 roughly, and then we got out of the car at 7:21 roughly to look at it. So, at most 25 minutes in between looking at the moon.
25 minutes beforehand, before 7:11 is what you're saying?
No, I went there about roughly 6 of. I knew I only had a couple minutes before they closed. I got there just as they were closing, and I got back 7:10 roughly, and then he texted me that right around that time period, saying I'll take a coffee. We got in the car because it was cold, and then we realized at that point we didn't reset the clock or the thing. We got out at 7, whatever that time period, whenever it started, probably a minute before that, because before we went to the camera, I looked up at the moon. So say 7:21, or 6:55 to 7:21, 26 minutes at the most. I noticed that the Sea of Crises had rotated. I did not think it was a sudden jump. 6:55 to 7:21.
Okay, so I've just put in, say, 30 minutes. I can make that 25 if you prefer. Make it 25. Okay, so I'm just going to step this back, and that is, so we're not really seeing any rotation there between 6:56 and 7:21.
Nope.
Okay, Astronomy Live, are you still with us? Yes, I see we're
I'm here.
Launch there. When you've been viewing the moon or doing any time lapses, have you ever seen any sudden unexplained rotations of the moon?
In 15 years of having my LX200, no, I have never seen anything like that.
Right. So Occam's razor and all of that, what do we suppose would be the more likely explanation that the moon, that great big rock in the sky, regardless of how far away you might think it is and all of that,
or whether we think it's a rock,
or whether you think it's a rock, or whether it's whatever, suddenly rotated in the sky?
Do me a favor. Go forward one more clip.
How far?
One more.
1 more minute, or 1 more click of 25 minutes?
What are you actually showing here?
So this is Starry Night Pro version 6. We're showing the moon on February 16th, 2019, as seen from Mesa, Arizona, United States. I've got the time.
So you're showing me a model,
a computer.
Yes, it's a computer. It's CGI. It's computer generated imagery.
Which means
simulation.
nothing.
It's not real. But the funny thing is about this. Did you see my little video of the occultation of Saturn by the moon the other night?
No.
Okay, I played that in place of our Hangout when I said that the Hangout wasn't going to go ahead because Mike wasn't available. And as it turned out, I felt like I had a hangover. I had a splitting headache because I'd been up until 3 o'clock in the morning, that morning, filming the occultation of Saturn by the moon. And the funny thing is that the CGI simulation, this software program, was able to give me a perfectly accurate prediction of what I was going to see just after midnight on Friday, April 26th. It showed me exactly when Saturn was going to disappear behind the back of the moon at 12:33 a.m. and it showed me exactly when Saturn would reappear at 1:44 a.m. And you know what? The funny thing is that when I went out with the LX10 telescope and the P1000 camera, which has kindly been loaned to me by Boatface, thank you, Boaty, it happened exactly as predicted in this crappy old CGI software program that I'm using here. How about that?
I have no doubt, but if the programmers aren't expecting or know about a rotation in the moon, they're not going to put it in there.
And how
That's
do
a
you
good point.
explain?
So, you know what we should do? Let's look at some other real videos, not CGI. Can I share my screen?
Yeah, okay. Oh, yes. Now, I was hoping that you'd get to these.
Good. All right. So let's see. Screen share.
If they're the same ones, then there are some other issues that you need to address as well.
Yeah. This okay. So let me get this out of
Hey,
there.
Mike.
Okay. Yeah, Rich.
You continue on. I'm going to have to take about a 20-minute break. I got to go do something.
Okay.
And I'll be back.
Thank you.
Oh, you're welcome. I'll jump back in if you're still going when I get back.
Okay, thank you.
Okay, so let's see here.
You might want to go full screen on your video as well, so we can see it nice and big.
Yeah, I'm trying to. This is oh, okay. So this is one that Rich put up on his where is that? Dang it. I lost the one from BLMS, but I can find it. Okay, let me make this guy big. This is a guy from Germany that he's also asking the question. Hold on, I gotta hide that. All right. But right here, let's see if it'll play. This guy. Okay. He's just taking shots throughout the night of the moon also. And then he gets to this point, and what is that? 23:31. And I think I went past it. Okay, I gotta go back. There we go. That's what I wanted to get to right here. Except for I want to go back to where that orange line's not on it. So very sorry for this. I had these all ready to go. There. Okay. So there's 2018, December 24th, 1927. Here's 2 hours later.
Mm-hmm.
Okay, you see the backwards rotation, right? Now, it's not proof of anything. Maybe he rotated his camera, right? But you see it. Somebody else has caught it and wondered what's going on. All right. Now,
do we know if he was using an equatorial mount to begin with?
No, he was just taking stills through the night.
Okay, so then in that case, we already know field rotation is going to be a factor.
Field rotation doesn't go counterclockwise.
Yeah, it does. It does. Okay, let's just hold it there, because I know that you've got other examples that you want to show, and I'm more than happy for you to go ahead and show those. But let's address these one at a time, so we don't end up with a gish gallop of video clips. Okay, you very
Now wait a minute. Now that's not very fair. You showed us CGI for 10 minutes. And I'm only going to get a minute and a half from real footage.
Well, you're actually going to jump to a different clip, aren't you?
Yes, I am going to jump to a different clip.
Yeah. So let's do one clip at a time, and then we can address them properly. Okay. Now you very adequately demonstrated field rotation in your video, which I sort of re-uploaded as a demonstration for Rich, so that he could understand field rotation. Because a lot of flat earthers, and I believe, if I'm not mistaken, even Rich at one point was denying that field rotation was a real thing. Okay.
Yeah, there's problems with it, but yeah, I understand how it can work.
Now you're looking at counter rotation here, and you're saying that that's not normal. Well, in fact, it is normal, and this is one of the reasons why I've got Starry Night up, so that we can actually look at what happens. And before we went on air, you and I actually talked a little bit about this, and I explained to you that what happens is that when the moon is rising, say in the northeast, and then it crosses over into the southern half of the sky, arcs around your sky, and then sets back down in the northwest, you are going to get that counter rotation. Astronomy Live, would you like to expand on that?
No, go ahead. I'm just working on something here in the background, but go ahead.
Okay, so what's happening is you've got the moon is crossing from one half of the sky to the other. And with your understanding of what's going on with field rotation, you should then be able to connect the dots and understand that because you're crossing from one half of the sky to the other in an arc across the sky, then you're actually going to get that opposite rotation at one point. And we do actually see it in the simulations. And the simulations,
as a matter of fact,
you agree with what you see in the real world.
Okay, well, I'm not necessarily interested in simulations. Do you have actual footage, maybe Astronomy Live? Do you do either one of you have actual footage of you filming a time lapse of the moon from rise to zenith, and that you can show me counterclockwise field rotation?
Well, certainly I could try to film counterclockwise field rotation specifically. I haven't aimed for that specifically in the past, but I do have, beyond just CGI, beyond just Starry Night Pro, my own spreadsheet shows this being predicted based on the moon's position in the sky and the expected amount of apparent rotation of the moon.
So no footage, though. No actual footage that we can watch where the moon's rising and with the Sea of Crises at top, let's say, and during the rise to zenith, the Sea of Crises counterclockwise rotates. You have no actual footage of that. I've never looked for it. This is all new to me. This whole lunar leap, everything, all this is new to me, and I've barely begun to start scouring some other footage out there.
Well, like I said, I haven't specifically aimed to film that. If I wanted to do that, I certainly could. That would require filming the moon north of the north of due east when rising, or north of due west when setting. But either way, yeah, I could definitely do that. But the thing is, I already know that it's supposed to happen based not on Starry Night or Stellarium or anything else, but based on my own calculations of the amount of expected field rotation and the angle of the moon, it should appear to rotate counterclockwise.
I understand and respect that. I respect your brain for being able to do that kind of a spreadsheet and to think that all out. But you got to understand that from Rich and my point of view, we don't believe that the moon is a rock orbiting around the Earth. So what we believe is your whole heliocentric model is built on a mathematical construct that you can make match to what we see go across us in the sky. So the fact that you're able to build make a spreadsheet and try to predict this is what's going to happen in this and this, it doesn't really amount to much, because I can say, okay, the heliocentric model is real, and because it's real, I would expect this to happen. That doesn't mean that it's because the heliocentric model is real. You know what I mean?
Can I just comment? I actually find that statement quite astounding. I could understand flat Earth believers or other conspiracy believers saying, you know, or being critical of programs like Starry Night that I've got on the screen, or I will have when I'm sharing. But it's another matter when somebody, an individual like Astronomy Live, who has the skills, the ability to actually sit down and write his own spreadsheet using mathematical calculations to actually predict such events. You know, he's not relying on some third-party piece of software that the powers that be have supplied to him. He's sat down, he's actually done the hard work and the calculations and worked it all out for himself. And the incredible thing, let me finish. The incredible thing is, just like the predictions of the occultation of Saturn, his predictions actually work 100%. And he has demonstrated this time and time again when he's been debunking particular aspects of claims on YouTube, such as SDO eclipses and so forth. Go ahead.
Did you want to say something, Astronomy Live? We both started talking at the same time.
Well, yeah, I will in a minute, but I agree with Daz. It's incredible because this isn't just Starry Night saying this. This isn't just Stellarium saying this. These are calculations I worked out myself. This isn't NASA or someone else telling me how to do this. I figured this out myself based on just simple first principles. of how the sky moves, of the moon's orbital elements that I copied out of a book that is decades old. And all it gives me are coordinates for the center of the moon. It doesn't tell me how the moon should appear to rotate in the sky. The rest of that I worked out entirely on my own, and it matches reality. It predicts this apparent rotation, and it matches reality. So when something is able to have that kind of power, that it makes accurate predictions about the future, then that should tell you that it's a superior theory, and you should abandon other theories that don't have that predictive power.
Okay, so then what you're saying is the ancient Babylonians that's at least the oldest record we have of the solar cycle. All these ancient people from way back before Christ lived who could precisely calculate the minute of the eclipse, what kind of eclipse it was going to be, to the point that when I filmed the January 31st, 2018 blood moon, I can tell you when the exact same moon is going to happen in the exact same place. I can tell you now, because people that believed the earth was flat and heavenly bodies were orbiting around us predicted all this. So you're kind of giving yourself a pat on the back to say, yeah, we've looked at the sky and this is kind of what the moon does over some years. So it's probably going to do that again. You know what I mean?
That's not how this works, though.
Okay, well, okay, then let me just ask one question. Is it because flat earthers are the ones that came up with the solar cycle? Does that prove that the earth is therefore flat?
No, of course not. But we're not talking about the solar cycle. We're talking about field rotation. We're talking about field rotation, and these calculations are much more accurate. These calculations are much more accurate than what they were able to make in those times. These are far more accurate calculations.
Yeah,
the calculations you can find on NASA's website are taken directly from the solar cycle, which was pre-Christ.
No, they're not. No, they're not.
Yes, they absolutely are.
No, they absolutely are not. They absolutely aren't. The calculations on NASA's site, if you go to the Horizon system from JPL, it provides you the most accurate ephemeris you can get on just about anything, whether planets, positions of planets, asteroids, moon, you name it. It is not based on ancient calculations of the moon. It's based on much more modern theories, based on actually calculating how gravity affects the moon caused by Earth.
So I will get that information. And I will get that information for you. And everybody has heard you say, no, it's not. I will get that information for you, and I will post it.
I will show you. No, I will show you. I will show you right now.
Fantastic.
The Horizon system is actually based on much more accurate calculations.
Anyway, okay, all this is irrelevant. What I want to know is if you can calculate counterclockwise field rotation, why in all your thousands of hours of astrophotography have you never captured it? That's all I want to know. I'm not saying you can't. Why haven't you?
Well, two reasons. One, no one's asked me to. Two, I predominantly polar align my telescope when I do these kinds of webcasts. So in that case, you're not going to see it because I'm polar aligned. Like in the image I'm presenting right now, I specifically set out to show the effect of field rotation here, but I got a late start. At that point, the moon was already basically due east in the altitude azimuth view, so I didn't capture the counterclockwise rotation of the moon because I wasn't aiming for that. I was just trying to show at a basic level, here's the effect of field rotation in altitude azimuth versus no field rotation in a perfectly polar aligned view. And if you watch this webcast that I did, where I did this back in February 19th, you can see that there is no field rotation whatsoever in the image on the right. In fact, it's so accurate that when I blink between them, the only rotation you see is actually caused by diurnal libration of the moon as the Earth rotates from one position to another. And this actually causes a slight stereo effect where you can see the fact that the moon is actually three-dimensional and spherical. So you see an apparent rotation of the moon itself. This is caused predominantly by diurnal libration over the course of the hours of the webcast. And so, again, this provides more evidence for the rotundity of the Earth and the moon, and also shows that the polar alignment was extremely accurate because there's no field rotation there, no rotation at all other than that produced by libration.
We got zero whatsoever except for that one time. And then it stayed that way all the way through, even past meridian crossing.
Rich, you're back. Good.
Hey. Okay. I just want to present my screen before we go back to the videos that you were presenting there, Mike. So again, this is Starry Night. We've got the same date. No, we're on February 16th now. February 17th. It doesn't really matter. This is the following morning, 5:20 a.m. I can wind this back if you need me to. But what I've actually done here, that's an all-sky view of your location, Mesa, United States. North at the top, south there. You notice that west is on the right instead of on the left. That's because we're looking up at the sky. Unlike a road map, this is designed to be held over your head, all right? So let me just bring that up just so you understand what's going on in the view. That's our horizon view, okay? And this top green line is the track that the moon took from rising in the northeast or east-northeast there, crossed the sky below the zenith there, and then set in the west-northwest there. But when we look at this in the all-sky view, as if we're laid flat on our back out in the backyard looking up at the sky, straight up, okay, north, south, east, west, you can see the path, and let me see if I can turn off the ecliptic just so we're not confusing things there. This path here is the path that the moon took across your sky, at least in the early hours of, no, that's right, that's from the 16th through to the 17th. So we're actually on the right day, even though we're on the 17th. Okay, you can see that the moon actually rose in the west-northwest. So it's actually in the northern half of the sky. So there's the northern half of the sky. There's the southern half of the sky. It's risen in the west-northwest, and then it has actually crossed over into the southern half of the sky before moving back into the northern half of the sky. And when this happens, you will get some counter rotation, if I'm not mistaken. Correct me if I'm wrong, Astronomy Live, please.
No, that's correct.
That's correct. Okay, where you've got the
and what's the reason for that? Why would you get counterclockwise?
Field rotation, as Mike adequately explained. When you're actually following an object across the sky, it appears to rotate. It doesn't matter whether it's the moon or an aeroplane that you're photographing, or as somebody in the live chat said earlier on, you will find the same thing happening with constellations as well, with field rotation. Okay, if you're looking at the very familiar constellation of Orion, which is in the sky at the moment, you will also see Orion rotating around the sky as it crosses over from east to west. Field rotation is something that some people have.
You don't have to go into detail. I understand what field rotation. Okay. I just wanted to know what your answer was, and still we had equatorial mounts that both sides agreed would take that rotation out.
Yeah, but you were talking about when you went out for coffee and you came back and you said that you saw the moon.
Right, and you clipped between the times there, and you saw how much the moon changed in the sky. Not enough for field rotation.
Well, your only evidence that you have are your videos, and unfortunately, we've got 7 minutes of missing video. The apparent rotation in the videos that you presented doesn't agree with each other. You've got 10 degrees difference in the rotation.
Do you agree they both rotated counterclockwise?
Yes, I do. And I
do you think they purposely just went out there and did that?
I also agree, and I'm sure you would agree, that the rotation is not consistent. You've got 20 degrees rotation in one, you've got 10 degrees rotation in the other, according to Mike.
Absolutely, no doubt about it. And if we were expecting a sudden rotation, we would have done it differently, like we're doing it now.
Right, and then we've got P&K Space Imaging, who were also filming at the same time, and yeah, unfortunately, they manually rotated their camera. But,
so we have no idea. So that's absolutely useless. We have no idea how much they rotated it.
And we don't know that they didn't rotate it at exactly the time that you claim that you saw your rotation. But then the next problem that we've got...
No, the time was right.
Rich, let's not talk over each other. I'm happy to hear you out. The next problem is, as I've demonstrated, is that when we properly sync up the two videos from you and Mike to the latest part that we can, we still have 3.5 seconds of discrepancy between when the moon leaped in your video and when the moon leaped in Mike's video. And as Mike has explained, 1 second equals 5 minutes. So we're looking at least 15, probably 17.5 minutes of difference in time between when the moon leapt in your video and the moon leapt in Mike's video.
Well, it
And
seems to me
what is the most likely explanation? Well,
that one missing video, just about the right time.
Hey, while you're there, Dazza, on that screen, can you go back to where you had the white line arching over? You were showing like the horizon view. I just wanted to ask something real quick. Now, can you keep it going? Can you make it small? Yeah, so that's what I want to see. I want to see it touch. So, okay, do you see where the N is for north? The N?
Yep.
Yep, right there. Okay, now, don't move it. Move it back. Orientate it the way it was. Okay, the very first dash on that white arch, the very first dash on north, okay, can you point at that? Yep, the very first white dash, the horizontal dash there. Not the line, but up a little bit. Yeah, right there. You got it. That first dash. Now, for field rotation, as the moon now go all the way, just follow that dash all the way across. We're going to say that dash is the top of the moon. It's the Sea of Crises. Follow it all the way around to south now. And which way will that dash? It's going to be the first thing to go sink behind the Earth too, right? It's going to be the first that rises up.
Path of the moon.
What's that?
That's not how field rotation works. That's not what causes field rotation there. That path of north to south, that meridian line there, and the hash marks on the meridian line, that doesn't indicate how field rotation will appear to move as the moon rises and sets.
Oh no, but why doesn't it? Because that's what I think makes perfect sense. If the Sea of Crises rises in north, and I've seen other people, other Boll Earth astronomers say the same thing, that basically the moon is being drug along by the Sea of Crises. It pretty much just follows the Sea of Crises across the sky and starts with the Sea of Crises at the top when it rises and it sets with it at the bottom. What do you think about it?
That's a rule of thumb, but that's not the exact reason, nor is it an exact calculation. Okay. Now, if you want a more exact calculation.
No, I don't want a more exact calculation. I want to ask you a question.
You do if you're asking about the counterclockwise.
No, I'm asking if it does rise if it rises at 360 degrees, dead top, the Sea of Crises, where's the range that it can set? Okay, I'm saying it rises at 360.
Look, you're trying to ask about the counterclockwise rotation, and let me explain something here. You can make a much more precise calculation.
Counterclockwise rotation. I'm asking about field rotation.
Yeah, counterclockwise field rotation.
Okay, so you started off, you said, yeah, as a general rule of thumb, it rises with Sea of Crises at top, sets with Sea of Crises at the bottom. What is the most discrepancy? Can it set with the Sea of Crises at top? No. Can it set with it at 90 degrees? 45? I'm asking, where's the play? Because in
if you want a more precise answer, here's what you do. You take the coordinates of the center of the moon, okay, right ascension and declination. What you're getting, field rotation, is the misalignment. It's caused by the misalignment between the equatorial coordinate system and the altitude azimuth coordinate system, okay? So you're looking based on the altitude azimuth coordinate system when you're looking relative to the horizon, okay? Up, down, left, right, azimuth, altitude. Right. The way that the moon moves in the sky, you need to account for field rotation, and the way you can do that, if you take the center of the moon, its coordinates in right ascension and declination, convert those to altitude azimuth coordinates, okay? And then take the coordinates of the north point of the moon, the northernmost point of the moon, in right ascension and declination, convert those to altitude azimuth, okay? Now look at that line extending between those 2 points and how that line moves. That will tell you how field rotation is affecting the moon from rising to setting. And that is basically exactly how my spreadsheet works. That's all it is. There's no magic behind it. There's no fudging the numbers. It is simply calculating how the moon should appear to move according to the conversion from right ascension and declination to altitude azimuth coordinates.
Yeah, I'm not arguing field rotation. Okay, I understand field rotation. I understand it. Daz is under the impression that Rich thinks it doesn't happen. I think Rich is just doing some questioning, just like I am. But I'm just asking a simple question. If the Sea of Crises rises at the top and the moon is just going straight around in orbit around the Earth, and it's not rotating left to right and, you know, side to side from our view, then shouldn't the Sea of Crises also set in the west at the bottom? Shouldn't the Sea, if it's the first to rise from the east, shouldn't it be the first to set in the west?
You would think.
I'm trying to understand your question. Okay, so you're asking.
Yeah, you start filming the moon. You want to get it right when it's rising out of the sea. All right. And it comes up with the Sea of Crises on top. It's the first thing that pops up out of the sea. It's the Sea of Crises.
I'll just interrupt there while you guys sort of get your heads around the question here. You see my screen. Where is the Sea of Crises in this view?
Oh, probably what, 280 degrees? 275, 280, somewhere in there?
Right about there?
Yeah.
Okay, and the moon is just above the horizon here. Now, if you're feeling a little bit confused by the view, this is because it's the view from my location here in Tauranga, New Zealand, in the Southern Hemisphere. But the same date, this is moonrise on February 16, 2019. Okay, and you see that the orientation is different. And what I'm going to do now is I'm going to zoom in and I'm going to run time forward, and we're going to see what happens with the rotation of the moon. So you can see it tipping over counterclockwise. Remember, the moon is crossing in the northern half of my sky, not the southern half of my sky. So it's tipping right over.
But it's not, the moon's not actually doing that. That's just from our view because of the field rotation, correct?
Correct. Okay. Now, the next thing I'm going to do is I'm going to bring this back up again. In fact, I'm going to swap back to your view. Here is the moonrise. I've got the daylight turned off at the moment, so we're seeing the stars in the day. It's 3:21 in the afternoon, February 16, 2019. And we've got the moon just above the horizon, so I can do the same thing. But the other interesting thing here is that we've got the constellation of Orion. So I'm going to turn on Orion as a constellation so we can visualize, and we're going to see what happens, just like we did with the moon.
I'd rather just see the moon. I mean,
well,
we're going to disagree because I think Orion's very close, so it doesn't matter.
If we're talking about field rotation, then
show the moon. That's what we're talking about, please.
Yep. Then this is going to be an excellent demonstration of what happens with field rotation, even when you're looking at constellations. So there is Orion heading across the sky. We've got our 2 feet planted on the ground, Alt-as-like, and we see that Orion is actually tilting as he goes right across the sky. And the same thing happens with the moon. So that is field rotation. It doesn't matter whether it's the moon, doesn't matter whether it's an aeroplane or a constellation. We get the same thing.
So please show the moon on that date.
Okay.
And while you do this, I want to put in mind a thought experiment, okay? Because this happens with the sun as well. Now imagine you're at one of the poles near either the North or the South Pole during summer, during solstice, and the sun is traveling all the way around the horizon, okay? It never sets, right? But it does go higher and it does go lower, and it will exhibit field rotation unless you're exactly at the pole. So let's say you're at 63 degrees north or 63 degrees south, and it just touches the horizon at midnight, okay? Local solar time. It will appear to go through its full cycle of field rotation, right? So as it turns clockwise, at some point, just as a simple thought experiment, it's got to turn counterclockwise to come back to the same location. Where will it do this? It will do this on the opposite hemisphere of the sky, right? So as it touches the horizon, obviously it's not going to touch for very long and it won't undergo much field rotation at that point, but it's going to exhibit that full cycle of field rotation while above the horizon. So the moon doesn't set directly east or west, and generally speaking, and from most locations it will set somewhat north potentially of east, and somewhat north potentially of west. And so you're going to see part of that cycle of counterclockwise field rotation. It's expected, it's normal, it agrees with my calculations, it agrees with Starry Night Stellarium, and I know those things don't really matter to you guys, but you know, if I film this, if I set out and say, okay, I'm going to film this deliberately, and I aim for the moon when it is as far north as it's going to get declination-wise, so it's going to rise as far north of east as possible, and I film that rotation, and it matches my calculations, what will that prove that my calculations haven't already shown? The fact that the calculations match up with reality, okay, but I kind of already know that from years of experience with this spreadsheet, but I'm willing to do that again. I'm just wondering what additional evidence that's going to provide that I haven't already provided. Other than
I just want to see the simulation, please.
Do you want to see the moon moving across the sky? So again, 1 minute increments. It's 3:21 p.m. Let's run it forward. And I'm also tracking the moon's path across the sky as we go. See if Crisis up there. And there's a sudden rotation across. We're just past the meridian. Was that white line? And
Why would it be, Dazza, why would it be sudden?
it's just the geometry. It's the same thing. If you're filming an aeroplane crossing the sky, you're going to get to the point where it comes up to the highest point, and you're going to have to make a sudden turn. It's just the same thing if I'm filming the International Space Station going over. You know, it's nice and easy when it's down lower to the horizon, but as it gets high up in the sky, I've got to make a sudden turn and rotate my camera around to follow it. And that's where you get that sudden rotation, because it's crossing the meridian.
All right, guys, I'm going to go. I think we've beat it to death.
Well, thank you for joining us, Rich. I do appreciate you fronting up. As I say, it's more than what most people would do, so respect to you for that.
Yeah.
Before you go, I just want to make one offer here real quick. Because you guys say you've got the ability to run your cameras off external power, which is great. I do the same thing with my Canon T5i. I will be glad to film the moon polar line from my telescope and broadcast it live as I did before. And I will be glad to do that at the same time you guys are doing that at your location. And if we see some dramatic sudden tilt of the moon, then from both locations, then we'll know it actually is, you know, being caused by the moon. So anytime you guys are wanting to or willing to, I'm glad to provide that, provided the weather's clear and I have time in my schedule. So, you know, if you guys want to do that, I will get together with you and do that. And we'll do simultaneous webcasts of the moon on our channels.
Okay, and where are you located?
I'm in Florida.
Okay, that's cool. Well, Mike is doing it a lot. My particular interest is the last roughly 2 to 4 days before full moon. Somewhere in there is where we've been noticing this. And the other thing is in the same cycle of the moon, so it's rising and setting pretty much the same time one night after the other. Just going back to the one thing I said about the Sea of Crisis being at 12 noon. In the last cycle, for example, it was at 12 noon when it rose. The next day, I was going over Mike's house to take him these video clips, and it was at the 5 of maybe even 10 of position, 10 of noon. So somewhere along one day, it rotated counterclockwise in the same part of the sky.
Well, it's never going to rise from the exact same part of the sky from one day to the next.
Because
It's not that much difference in one cycle, though. Not one day to the next.
It's a bit of a difference.
It does, actually. It moves. If you look at its position, moonrise position and moonset position on the horizon, you'll find that there is quite a difference. It does slow down as it gets to the point at its furthest point of elongation in its orbit before it starts coming back. But sort of midway through, it's actually moving quite a bit along the horizon each night.
Okay, I'll check out the specifics on that.
And
Maybe.
just like Astronomy Live with his offer, I don't have certainly the energy, even though I might have the ability, the energy to do live streams, because I do suffer from chronic fatigue. But what I can do is if you guys ever want any detailed simulations from Starry Night, and yes, I know it's CGI, but it is detailed and it will give you an accurate prediction of what you should be seeing on the night, I'll be happy to provide any simulations that you request.
I really appreciate that. And as far as the other offer, I think it's probably better to go through Mike because he knows when he's filming.
Mm-hmm.
So,
Okay,
yeah, good night to everyone. Appreciate you all being here too. And take care, guys.
Good night, Rich. Thanks for coming along, man. I'll talk to you soon.
Alrighty. Bye-bye.
thank you.
Okay. Hey, guys, so Astronomy Live, did you come up with a simple answer on that? If you're seeing it rise over the ocean, Sea of Crises dead center, should the moon set in the west, Sea of Crises pointing straight down?
Well, this goes back to kind of what I was trying to allude to before with my thought experiment about the sun and being 63 degrees north or south. It depends on your location and how that is oriented relative to the moon. If the moon is traveling well north of west or east as it's rising and setting, then you're going to get a lot of counterclockwise rotation. And so you may not see what you expect to see with the Sea of Crisis. But if it's rising and setting pretty much due east, due west, then in general, yes, it will rise with Mare Crisium up and set with it down. But this all depends on your location and how field rotation affects it.
Okay, and if it's off a little bit, if it's not due, I think the one I got was right when it was. Since I've been in this place, started shooting the moon, it started rising northeast and setting northeast. Then over the progressive nights, it got to a point where it rose dead east, set dead east, and then today it rose southeast and set dead southwest. I know I said that middle one backwards, but yeah. So it's going through but it was right about the time it rose. It rose dead east and set dead east for me. So in that situation, the Sea of Crises, if it rises on the top, it should theoretically set first.
Well, okay, at the phase of the moon you're showing there, I can tell already it's waxing waning crescent. I can see it. You're sharing it.
Oh, I didn't. Daz, you didn't tell me I was sharing. I'm just playing around here.
Yeah, you control your screen sharing, so yeah, it pops up if you otherwise.
Oh, I thought you had to do something.
Yeah, I stopped my screen sharing, which means that it's over to anybody else who's sharing.
Oh, okay. This is one I just shot this morning. I put this one on the Alt Azimuth mount and just did some still shots. But so I'm not getting. I don't think I got any counterclockwise rotation. They're time stamped. I'm getting the clockwise field rotation all the way. To the end, but I didn't get any counterclockwise. And that's why I was making a big point about that, because I'm not doubting your math skills or that you say it does happen. I've never seen it. I've never seen counterclockwise rotation as field rotation, but that doesn't mean it doesn't exist. I mean, every stuff I've shot, it's been like this, it starts rotating clockwise from the very beginning. It's already right there. It's already rotating clockwise from that to that. That's what, 247, 356. So an hour and 10 minutes later, it's not even close to zenith, This is just now.
All right. I do want to go back to the video you showed from Germany on YouTube, if you've still got that open.
Yeah, I do. I didn't even know I was sharing this. I was just looking at this myself because I just put it in the computer. It's on my SD card. I haven't even loaded it in. Let me find it here. All right. Let's see. Okay, so this is the Germany one.
All right, 926. Okay, so go back earlier in the video. Okay, I just want to see where the timestamps were on that. So it was 1927 local time, right? So that was Germany is about 2 hours ahead of GMT, so that would only be about 1727 GMT time, and then so there. Well, okay. Actually, I don't know if he's got that set too.
He might already have it. UTC, huh?
Yeah, don't know. It's not so clear. But I just want to show. Okay, so that was December 24th. December 24th, 2018. So there's that. let's go back to 17. Okay, actually that actually does line up pretty well. So 1727 and sorry, 1927, but 1727 GMT. Skip forward again to the other picture you showed from that video. Yeah, 926. Okay, so it's going to be about 2 hours later, almost exactly.
Yeah, and remember, I can pull these up anytime for you, Mike, using Starry Night if you need any simulations or whatever.
Yeah, and I'd be curious, Daz, if you could set your Starry Night for say Berlin, Germany, on December 24th, and show what that shows. Because here's what I show with if I switch over here. Can you see my spreadsheet now?
I can.
There we go.
Hold on. Open you back up. Yeah, I can.
Okay. So here's my spreadsheet set to December 24th, 2018, 1727 Universal Time. Here are the coordinates for Berlin, Germany. Altitude and azimuth of the moon expected, so it should be low over the horizon, 94% full, 46 degrees from vertical with the illuminated limb facing down towards the horizon. Now, so if I go forward 2 hours to 1926, that orientation increases away from vertical. So that indicates it actually is consistent with a counterclockwise rotation of the moon over those 2 hours. That's expected. If I go forward further, eventually that becomes a clockwise rotation and starts to decrease in orientation relative to the horizon. So it starts to become more vertical. Let me skip forward here to, actually I'm going to have to do this as one and change this to, oops, I'm changing the day there. That should be, yeah,
well, that's okay. I appreciate the spreadsheet and all the work you put into it. I guess what I want to do is I want to see it. And I guess you could say this video I'm showing you right there, I'm seeing it.
Yeah,
so,
you're seeing it there, and it's consistent with the expectations. But I'd like to see it from Daz's perspective too, if he's able to show from Starry Night.
What I'd really like to see it is on my own footage, like the one I just showed you that I took today. I'd like to see that counterclockwise rotation.
Okay, so this is a view from Berlin, Germany on December 24th, 2018. Was that the correct date?
Yeah, that's correct.
And what times did we want to check? I don't know if it was on daylight saving or not. This is
17 something. Let's see.
17. Yeah, it's going to be, so universal time, it's going to be
1727.
Was it UTC?
Yeah, UTC 1727.
1727. Okay, well, that's helpful. Okay, so there's the view at 1727, December 24th, 2018 from Berlin, Germany.
Okay, so then go forward 2 hours. You could just do a jump at 2 hours.
Hold on, don't go yet. I was going back to my screen to find the times. Okay, that's the one at 1727?
Yes.
Okay, and then 2 hours ahead?
Exactly 2 hours, 1, 2.
Just about. Yep, so there we can see the counterclockwise rotation as expected from Starry Night as well.
Okay, all right, so that one is expected. That's the first I've seen of that. I wonder why I can't catch that. That's what I was saying before. I'm not telling you it doesn't happen, but why don't you have any footage of it? Why can't I find any footage? I want to see that clockwise rotation.
Well, like I said, I'm happy to, deliberately film that for you. Obviously, I'll have to plan the observation, but let's see here. Let me just see what the situation is for tomorrow morning moonrise at my location. I'm not sharing, am I? I don't want to show my coordinates.
No, I'm sharing at the moment.
Okay. I just want to make sure I don't accidentally dox myself here.
Just in your preview there.
Okay. Good. All right, let's see. So moon is 38% full. It's 1 a.m. Let's go to 4 a.m. So 4 a.m., negative 34 degrees sun.
Yeah, as Charlie in the live chat has said, Mike, zenith and meridian, we really have to take these two factors into account. Looking at where the moon is, where it's crossing the sky, the path it's taking across the sky, and whether it's actually crossing from one half of the sky to the other.
Yeah. I'm having a hard time getting my head around why it would jump so fast.
Well, I highly recommend actually getting a program like Stellarium or...
I've got Stellarium on my computer.
Yep, have a good play with it. Look at these things, because that's a fantastic way to learn what's actually going on with orbital mechanics and all that sort of thing.
Well, I got a feeling what's going on is nothing close to what Stellarium is going to show me. As a matter of fact, I know it. But anyway.
Hey, Mike, you know they found bones on the moon, don't you?
What's that?
You know they found bones on the moon.
Who left bones on the moon?
Yeah, the cow didn't quite make it.
Oh, the cow. Oh, okay. Yeah, well, I'll tell you what, that cow had just as good a chance of getting to the moon as the Apollo missions did, or anybody else, or any rovers. They got the same likelihood of both of them happening. So, hey, while he's back with that, can I share again?
You want to share?
Yeah. I want to get back to the videos that you promised me I could do. Yep. All right, I'm sharing. All right. Okay. All right, so this is the one. This is the one that we talked about a little bit, or well, you made a comment.
Would you like to go to theater mode on that, or full screen, just so it's bigger? Yep. Perfect.
All right. So that's now you got to agree that's a pretty good mount there. First thing I want to point out, look at the so-called shadow. Does that look a little bit weird to you? Is that how the moon passing into an umbra should pass through and jump back and pass through and jump back? It did the same on my lunar eclipse video. So that's the first thing.
Okay, well, let's stop there and let's address that. As you do with your camera, Mike, as you explained, you stop your time lapse and you zoom the camera in or out or whatever. And the same thing happens when somebody is doing a time lapse like this, because the lighting is changing as the eclipse is progressing. So therefore, it's necessary to actually change the exposure settings on the camera. And that is why you'd be seeing a changing apparent shadow on the moon.
No, that's I hear you, and that's fine. No. Change. I see over here on the right. Yeah, it's getting brighter. I understand the exposure is getting different. That has absolutely nothing to do with that shadow. It looks more like a fog kind of coming, going.
Well, that's because you've got the you got the umbral shadow there, and as you get closer to that umbral shadow, it gets darker. Sorry, I got to mute my own video here. I actually filmed that same eclipse, and yeah, if you set the camera to automatically expose, the difference in gain can cause it to look weird, obviously. So let's see here. Let me share my video.
What about this? What about these little frayed edges? Why don't we have a nice sharp line?
Well, you've got Earth's atmosphere for one thing, and so you will have a gradual increase, and also Earth is not a Earth's got the penumbral and the umbral shadow, right? And so you've got, imagine you're standing just at the edge of that line where it's fuzzy. You look up in the sky, what do you see? The sun almost completely eclipsed, but not quite completely. And as you get closer and closer to that eclipse, you're getting closer and closer to total darkness in the image there. But it's not even totally dark there. If you are in that total darkness, what do you look up and you see? You see all the light from the sun refracted through Earth's atmosphere. You're seeing every sunrise and sunset occurring on Earth simultaneously. And so that produces the red color that we see during the eclipse. So I filmed this same eclipse and didn't really see that jumpy shadow. It's hard to tell here, but if I move my cursor up,
who's sharing right now? Because am I supposed to be seeing something from him?
Oh, you're not seeing me, I guess. Sorry. So Daz is still presenting you, but we'll get to it in a second, I guess. I filmed the same.
I want to ask you about this jump here. So you guys have seen the video. This little guy here, you're going to see the rapid rotation. Daz has pointed out that, yeah, but there was some time missing in there because the shadow jumps pretty big right there too. Okay, I can accept that, but it's still an EQ mount. So it doesn't even matter if, if they cut out 20 minutes and the shadow's up here afterwards, the moon should still be in the same orientation. So what do you guys, here it comes, see there?
Yeah, that That assumes they didn't rotate the camera in the telescope, but they very easily could have done.
Okay, so and that's what I'm saying. Why would they? So here's where we started off. Me and Rich caught this thing. I opened up our private conversations to everyone online, and the most boring 18-minute video YouTube's ever saw. Went through our text back and forth. We were shocked as heck. We didn't expect it. We were freaking out. All right, so it wasn't an intentional thing. And then after that, I went back and looked at my lunar eclipse videos that I'd already posted a couple of days before, and they had the same situation. Now, like I said, none of this is proof. I mean, I could have bumped the camera both times, but it's just getting a little bit odd when then we watch this video, which is a perfect EQ mount, and we see this happening, and the only explanation is, well, maybe they bumped the mount. Well, you know, it's kind of now who's grasping for straws. You know, you said I was grasping for straws, saying Rich might have adjusted his with the ball head instead of the other. You know, but now it sounds like you're grasping for straws. Here's another one. Now watch. I got one last one, and then I'll be done with my sharing. This one, I started looking. This was a news feed. It was a live news feed from 9 News in Denver on the same eclipse. Now this guy, he doesn't have it on an EQ mount, and it's somebody obviously just, you know, letting the moon, you know, he's just following it like this. But if you can, here, let me go big for you. You know, you can see the Sea of Crises staying the same. And this guy, I think he was smoking a little weed out there because it's legal there, and because a couple times the moon just disappears for a while, like he was racing. At one point, he's shooting the parking lot instead of the moon. But this, I thought this was interesting. Now he's changing sizes and changing orientations. But right here, right, he's gonna change it. You can tell it's a whole different shot of the moon. But watch the Sea of Crises. From here, it's coming. Oh, I don't got it playing, dumbass. All right, coming from here, and it'll jump over here. Okay, but do you see the difference there? Now it's a whole different shot. I understand that.
Yeah.
And it might even be a whole separate feed. Maybe they transferred a feed to a different news camera that was somewhere else. That I understand that too. But let's say the first feed was done by Daza. He was doing that first feed. Now, what's the first thing? Even if you're not using a EQ mount or out-as mount, whatever. If you're just letting it run like this guy's doing, just run out of the picture and then putting it back in, isn't the first thing you're going to do level your tripod either way? I mean, you're not going to be sitting there filming it with a freaking tilted tripod. So even if they jumped to another dude on another camera, why would his tripod be freaking crooked? Why wouldn't he?
It could be in a different location. It could be that although the camera or the tripod might be level, if you've got a camera in a wide field telescope, you can freely rotate that camera. There's nothing holding you down on terms of the orientation of that camera. In fact, it's actually tricky to get it perfectly oriented up and down, left and right. It's hard to get it actually perfectly level, the camera in the telescope, because the way that cameras attach to telescopes is you've got a round nose piece going in a round hole being held by a set screw. There's nothing there locking it into an orthogonal orientation. And when you slap that thing in there, you can orient it any way you want. That's why the other one changed. That's why this one could be changing. I filmed the same eclipse from start to finish with my equatorially aligned, polar aligned telescope, and it never jumped. The orientation was the same from the beginning to the end. So how do you explain that?
I don't know how to explain it.
Okay, I'll just make some comments too. Yes, so you could have 2 different locations, and yes, the tripods may be perfectly level, but with a different latitude, as I demonstrated when I brought up the view from here in Tauranga in New Zealand, with a different latitude, the rotation, the apparent rotation of the moon is also different. That's why when people from the US come down to New Zealand and visit, and they see our night sky, they're rather confused because, you know, the constellations are so unfamiliar, and they're upside down. Look at Orion. Orion is upside down. He's standing on his head. And, you know, the moon is upside down and all that sort of thing. So latitude doesn't matter whether you're in the northern or southern hemisphere. If you're at a different latitude, you're going to have a different orientation of your moon as well. So that's a factor. But also, as Astronomy Live pointed out, I've actually demonstrated this in one of my videos. I was down at the observatory one night, and we were looking at Jupiter and its moons. And I demonstrated this very fact about rotating the camera in the telescope because I think it might have been Dark Sky Watcher 74 I was debunking at the time, or somebody else who claimed that they had seen some sort of rotation. So I physically rotated the camera in the telescope to show Jupiter and its moon suddenly rotating in my video.
Oh, that's a good point too. Have either of you caught field rotation on the sun or on Jupiter or Saturn? Have you guys ever crossed the sky?
Absolutely. I've got a video of let me see if I can pull it up. I've got a video of Jupiter where I did some time lapse from stacking of the images over the course of several hours, and you can see dramatic field rotation in Jupiter. Now, let me pull this up.
Yeah, I'm trying to figure out how to stop sharing.
I can stop sharing for you.
Okay.
Stop presenting you at least.
Okay.
So can you see? I don't know if you can see my screen.
Yeah. So I'll present you.
I could for a minute.
Okay. Oh, can you see? Can you see me now? Okay.
Yep.
So this is some footage I filmed at Jupiter and Io quite a long while back. Actually, geez, I can't believe it's already been 9 years. That's amazing. Jupiter and Io crossing over it, and you can see the cloud bands of Jupiter rotating. Now, keep in mind, this was with a star diagonal that flipped the image vertically, so it's actually mirrored. And so it was actually, although it looks like a counterclockwise rotation here, this was the clockwise portion of the rotation. Nevertheless, you can definitely see the effect of field rotation over the course of a few hours with Jupiter and Io. So yeah, it definitely happens with the planets and everything that you see in the sky, not just the moon.
Okay. Okay. Very good. Thanks for answering that. All right, then. I got one last thing, and I just wanted to know about that Sea of Crises. So I'm asking if it rises top center, then generally it should set first thing down, right? So what I'm asking, you say it changes, depending on your latitude and this and this and this of the moon and 100 million other different things. What's the max? How far can it set off of bottom
I'd have
center?
to crunch the numbers on it. Honestly, I haven't crunched the numbers on that. Like I said, it's going to depend on a variety of variables, but it can be, basically you can expect roughly 180 degrees rotation from rising to setting, roughly. It might actually go a little bit beyond that, I guess, with counterclockwise rotation and whatnot. I don't know. I mean, it depends. You got to also account for lunar libration if you want to be real precise. I showed the effect of diurnal libration in my polar line view, flipping between those images. It's slight, but it's there. So you're asking for a number. And it's in my nature to give you an exact number based on actual calculations, not just roughly this.
Okay, well, I'll be looking forward to getting the exact numbers in, and I was going to show my video, but I wanted to hear what you said first. I wanted to get a maximum it could be at. But basically, what you're saying is going to be roughly 180 degrees. It's not like it's going to rise at 360. It's rise at the top and set at the very right or something like that.
It could. Yeah, I mean, it could. It depends on your location and everything. If you give me your location and the time, I can plug that into my spreadsheet and we can see what that shows compared to your images.
Sure. It was it was 4/17 this year.
Okay. 4/17. What time?
Well, from just rise to set. Rise to set.
Okay.
Yeah, I started shooting it at 10 after 6, but I think it rose at 5:35. But I started shooting it at 10 after 6.
Okay, what location, roughly?
Mesa, Arizona, exactly.
Okay. Let's get the coordinates from Mesa, Arizona.
You're still sharing Astronomy Live, just so you're aware.
Yeah, that's fine. Am I sharing? What am I sharing exactly? I'm sharing that okay, I'm sharing the browser window. Okay. Let's go over here. All right. Is that better? You can see it. You can now see the spreadsheet, right?
Yeah, we can see the spreadsheet.
Okay. So, okay, 417, it actually rose on the 16th by universal time. Let's go to 23. So you say you shot at 10 after 6?
That's when I started shooting, yeah.
Okay, so let's go 17, 0 hours, 10 after 6. Let's see, is that right? That's going to be 6. It's going to be 18. Yeah, that's right. That's 10 after 6 local time in Arizona.
Yeah.
Or yeah, Mesa, Arizona, you said. So at that time, the expected altitude of the moon, 11 degrees of horizon, 90 degrees azimuth, so almost due east. So I wouldn't expect you would have seen much counterclockwise rotation unless you filmed before that point. And then you've got an orientation of the moon 87 degrees from vertical, illuminated limb facing away from horizon. So let's see your images and see how that looks as it rises.
Well, you tell me what it's supposed to look like.
Well, that is what it's supposed to look like right there. Can you see the numbers?
Okay, so what, according to your spreadsheet, where should the Sea of Crises have been? On the degrees, 360 at top. Should it have rose 360 degrees straight top? Should it have rose to the right of the straight top? Should maybe 5 before noon, 5 afternoon? What's your spreadsheet tell you?
This spreadsheet's based on the orientation of the terminator. So let's see what it looks like with the lunar terminator.
By the way, where's it going to set? Pretty much due west?
Let's see. Let's go 12 hours.
While you're looking that up, I'll just read out a comment from Barney's Moon Channel. He says, Dazza, my lunar eclipse you shared on Facebook was on an alt-az mount and shows field rotation over 4 hours. Just thought I'd share that.
Yeah, I don't have an alt-az mount. I didn't then. The telescope I've got now, that Celestron, believe it or not, my brother works sanitation and somebody threw that out.
Oh, no.
So I've only had that for a couple of weeks and I'm just starting to play with it. And it's kind of pissing me off because I'm trying to, you can't mount a P1000 or 900 to the back of it with a, a T-ring, so I got the piggyback and then once you get certain altitude, it won't track. The motor's not strong enough. So I've adjusted it forward and, anyway, it's been a pain in my butt, but anyway.
Yeah, you got to counterbalance it.
Yeah, I didn't own that then, and no, it was definitely not a alt-az mount.
And just to let everyone know too, I'm going to wind this up soon. We're coming up to the 3-hour mark, which has been a pretty good effort. So, yeah.
And that's cool because I'm getting tired, but you know what? There was a million things I was going to go through with you that we just didn't get the time, but I'd like to do it again sometime.
Yeah, absolutely. And I'm more than happy to talk to you either in a live hangout like this, or we can talk via Skype where I can share my screen with you and answer questions, whatever, anytime. I'm sure Astronomy Live will be happy to do the same as well.
Yep. Okay. So this is the coordinates for setting. So about 274 degrees azimuth on the horizon.
274. Okay, so yeah, pretty much rose due east, due west, set due west, pretty close, right?
Within a few degrees.
Yeah, within 4 degrees. So, so in that case, since it was rising due east and due west, referring back to what you said earlier, if the Sea of Crises did rise 12 o'clock noon, it should have set, 6 o'clock. It should have been
not necessarily, because if you look at the orientation relative to horizon here, you've got only 25 degrees from vertical with illuminated limb facing towards horizon on setting. So it won't be the lunar terminator. If you use that as a reference point, it won't appear to be nearly as horizontal. It won't appear to be nearly as far from vertical during setting in this case, according to my calculations.
Okay. Well, here's what it looked like rising.
You want to share?
Yeah, I guess yeah. Can you do it for me, or do I got to do it?
I'll present you to everyone, and you're sharing.
So I don't know why your spreadsheet couldn't tell me where the Sea of Crises was going to be.
It's set up to do it based on the Lunar Terminator, like I said, not the Sea of Crisis.
I'm
Well,
sure.
I know, but once you figure the Lunar Terminator, you should be able to calculate where the Sea of Crises is from that, right?
Yeah, the spreadsheet
if I-
to do that. I'm sure Astronomy Live absolutely has the ability to pick any
Well,
point.
that's what I was asking him, and I gave him 10 minutes to do it because I didn't want to show my picture until he showed his math, because I was going to make sure he knew what he was doing with the spreadsheet.
Mike, have you ever sat down and written a complicated spreadsheet program?
Nope. Don't care, because math is not reality. Reality is one thing, and you can make. I'm very impressed that he can do that. That's fantastic for him.
Yeah,
but if somebody wants to ask a simple question, hey, which position did the Sea of Crises in when it rose? His spreadsheet should be able to tell him that. And if, well, it's based on the Terminator, well, adjust it then. Just adjust how far it's.
Okay, I'm going to need more than. Again, I'm going to need more than 10 minutes to adjust it, okay? Yeah. Calculating selenographic coordinates are something that an additional version of the spreadsheet actually does do, but I'm telling you right now, it takes a lot more than 10 minutes to plug in those equations.
Yeah.
Okay, fair enough. I stand corrected. I just thought you were typing away like a madman, and I'm like, why isn't he telling me where the damn thing is yet?
All I was doing was adjusting the date and time.
You see where it is, okay? Mm-hmm. It's rising about what, 3, I don't know, 45, about center of it, 345.
And I can see, although it is a very full moon, so it's hard to see, that it does look like the Lunar Terminator is at the bottom of the moon as it's rising, and it's roughly horizontal within a few degrees, right? I mean, if you draw a line from the northernmost point of the Terminator to the southernmost point, it forms almost a horizontal line.
Yeah, I can't even see it. My eyes are crap, man. Okay, so then 8, 10, 12 hours from now, this guy should be the first to rise, and he should be the first to set, right?
So no, not quite. Like I said, if you look at the spreadsheet, based on the Terminator, it was almost horizontal at rising, and it's going to be much less so at setting. It's only going to be 25 degrees from vertical at setting, according to my spreadsheet.
Okay, so tell me where to put my at 25 degrees, then where should this guy be when it sets?
Well, think about it right now. You're at almost 90 degrees Lunar Terminator from vertical. So to make the Lunar Terminator only 25 degrees with it pointing the illuminated portion down towards the horizon, you would rotate it only by 30. What am I saying? 90 plus 25, whatever that is, 115 degrees from its current orientation.
115 from its current orientation. So there's 90, 115. Let's see. Oops, I didn't mean to do that there. I didn't mean to do you. I meant to go ahead and see. This is where it was when it set. So,
okay, well, you got the horizon all wonky.
Yeah, I fixed it right here. I straightened it. That's the building next to my house. There's my horizon. There's the Sea of Crises. It rose here.
Yeah. It only set there. Yeah, it's about 115 degrees rotation, roughly.
Okay. So then it's not really a general rule that it should set opposite of where it rises in.
Like I said, you got to do, it's much more nuanced than that, and you got to do more specific and exact calculations, which is exactly what my spreadsheet was set up to do for exactly this scenario. So, yeah. I'm quite happy with that.
The real question, is you said that math isn't reality, but he just did the math, made the prediction, and your images matched it.
Well, I don't know. We'll find out if it matches it right now. What the hell? Why don't you let me add a sticker?
Mike, can I ask you a quick question?
Yeah.
Just can you tell me again, please, how long the time lapse, the maximum time lapse ran for?
How long the maximum? Like 50 minutes, you mean?
Yeah, 50 minutes, was it?
Yeah, 50 minutes is yeah, and then it shuts off.
And what was the maximum duration of the final video?
I don't know.
Wasn't it 10 seconds?
Oh yeah, 50 minutes and 10 seconds per time lapse. Yeah.
So 10 seconds maximum duration video equal 50 minutes of real time. Is that correct?
Say it again. I'm sorry. I was trying to do something.
10 seconds of maximum duration of time lapse equal 50 minutes of real time. Is that correct?
Correct. If you run the time lapse start to finish, yes, 50 minutes.
Right. Mike, didn't I just do math? Isn't math reality?
No, math is not reality. Math is a construct that we came up with to describe things in nature. It is not reality.
I just used math, and you actually agreed with me that 10 seconds of the time lapse was 50 minutes because we calculated it using math.
Yes, we have come up with, now we could change the whole number system, come up with whole different numbers, and then it would be a bazillion green seconds. Okay, you know, it's how we want to describe things. Math is not reality. It's a construct designed by humans to describe certain things. And we can describe it a whole bunch of ways. Right now, what do we got?
I guess there's a whole different video that we could do on that one.
Well, yeah, if you think it's reality, then you need to.
We're coming up to the top of the hour.
Yeah, yeah, we're done. I'm just trying to check this. Okay, so we got 82 and 82, 92, about 97 degrees. All right, let's see. Wait, 90. Yeah, about 97. 97 degrees. What'd you say it should be, 115? I'm getting 97, unless I'm counting wrong. It was. I know. I put it over it before, and it was centered. I think 45. So we got 15 plus 80, and maybe we'll give 2 degrees here to get down to the center of it. So 97 degrees. So that's a little bit off of 115. That's quite a bit off. But anyway, all right. I'm tired too, guys. Thanks for the chat. It's been real.
Before you go, let me show, sorry, I have myself muted. I thought you could hear me. Let's check this again. Let's check this again. Okay. Well, can you present me, Dazza? I'm going to share my graphics editor here. All right. So we've got your setting image, right? We've got the moonrise image, right? Okay. There's Chrysium. What happens if I rotate by 115 degrees? So this is 115. Can you see my rotate screen or not? I don't know. Probably not.
I can see you rotating stuff, yeah.
Yep.
But you can't, okay, you can't see the exact numbers. Let me see if I can present the exact numbers that it's showing. Okay, it's not going to give me that. Is that going to do it? Nope, that's not going to do it. Okay. All right, I'll have to do this. I'll have to do this the other way. I'll have to, hang on, let me clear out the Hangouts window so you can't see the URL. All right, and I'm going to share my entire screen like so. Okay. So, sorry for the Hall of Mirrors. I wasn't talking to you. So, okay, so let's see here. Here is the rotate tool. Where did it go? Let me just undo, select none. Okay, let me try to redo this. Okay, so now you can see the actual rotate tool, right? Just want to show for transparency purposes. I am rotating to 115. Okay, like that.
I see
this number right here.
Where?
Right where my mouse cursor is at. Can you see this?
Okay, yeah, I can see that. Yes.
Okay, so rotating by 115, and then line up the moon. Let's line up the moon. So the moon's size has changed here, as you can see.
Yeah, you're going to have to make it smaller. And you're going to have to, since it's stretched down, you're going to have to line the left side of the overlay with the left side of the,
well, the moon is
orange.
Yeah, the moon's quite a bit squished and quite a bit The magnification's clearly changed here quite a bit.
Got a lot of atmospheric compression there, and it's not a great image of the moon to start with anyway, is it?
Right. No, it's definitely not. But all right, I'll try to rescale it a bit here. It's going to be tricky to do this in GIMP, but try to get it closer to the actual size. Oh, no, don't do that. Didn't mean for it to go away. So the moon is going to be quite a bit squished by differential atmospheric refraction from the top of the moon to the bottom of the moon when it's that low on the horizon. But I think we can all agree that Mare Crisium is about 115 degrees rotated. I think
I can't agree with what you're doing right there, but
I'm just changing the.
You know what? We can just do it the way I did it and put the protractor over the first one and put a protractor over the second one. That's what I did. It was 145 on the first one, and you guys just saw what it was on the second one. I don't remember the numbers, but it ended up to what, 85, 90 degrees or something?
97 is what you said.
Yeah, so lay a protractor over there. I think Sea of Crises is
I rotated it by exactly 115 degrees, okay? Now, yes, the moon is squished. I've enhanced the contrast here to bring out the features a little more. But you can see as I flip between them, the orientation of all the features, all the Maria of the moon is the same between those images. One is squished by the atmospheric refraction, but the orientation is the same.
No, right?
Yeah, it is. It is.
No, it's not.
It is.
It's not. But anyway, I'm just going to argue with you about it. You know what? You were here. You want me to do it? Let me share the screen and I'll do it. I'll show you.
Hey, look, I've got to wind this up, guys. We're coming up to 3 hours.
Yeah. Okay. All right. That's fine. That's fine. Yeah. I mean, you could have just overlaid a protractor Astronomy Live and on both pictures like I did. So,
well, I rotated it by exactly 115 degrees.
Well, you could have just overlaid a protractor because your rotation, you didn't actually get the picture overlaid, and you didn't get the opacity right, so we could see it one on top of the other. You were just flipping back and forth, and it didn't look the same to me. And
the orientation looked the same to me. Like I said, the only difference between them is the squishing effect of the atmosphere there.
Yeah, okay. I'm sure that Astronomy Live will be happy to follow up on that and satisfy any concerns that you have about how he's presented it or whatever. But
well, I've already presented my own with overlays on them, and I know how it is. So I just wanted to know how far it would go because the story was basically 180, and that's what you were saying the whole time. And I kept pushing you, saying, how far off of that could it possibly?
You were asking me for a maximum number. You weren't asking me for the actual number at the date and time and location that you filmed it. And so I gave you the exact number at the date and time and location you filmed it. I rotated it by that amount, and what do you know? The features match up.
Wow, that's better for you, eh?
Okay, my man, if that's what you see, then that's fine.
Okay, so thank you, Mike, and thank you, Shawn Hufford, as well for joining us and just keeping an eye on the technical side of things. Do you have any comments you want to make, Shawn?
Oh, I've got many, but since this was supposed to be cordial and nice, I'm going to refrain from them until after this is not on air.
Right. Thank you, Shawn, and thank you, Astronomy Live, for joining us, and thank you to everyone in the chat. It's been an interesting hangout, and hopefully we've managed to answer some questions and maybe raise a few more as well. So thank you from me. Good night to everyone, and have a good night or a good day, depending where you are in the world. Thank you for watching.